So let's get started. How many people, most of you are here for the first part, right? Yeah, okay, not all of you. So the first part was recorded, so you can go check that out later if you want. This part is going to be very much the same as far as the way that it works and everything, but yeah, just more advanced examples or features. Many or several of these features, you'll wonder what use cases you could possibly have for them. But mostly the goal for some of those is more exposure to the feature than entirely being practical. So some of these things you'll be like, yeah, I don't think they'll ever use that. But it's good to know how they work. And some of these things I'd say don't ever use them. So we'll talk about those. But several of these things are going to be really practical. If you were at the last one, you'll know that the promises section that we did at the end was like totally a disaster. So we're going to do that one over again. So that promises are, because promises are actually a feature that you will use all the time. You're probably already using. So it's good to understand those. So yeah, before we get into this though, let's wake up a little bit. Everybody stand up, please. Okay, so if you're physically able, you can join us. If not, it's fine. But stretch your arms out in front of you and squat down and back up. That's an air squat. We'll do 12 more of these together. Ready? 1, count out loud with me. 2, 3, 4, 5, 6. Now I'm waking up. 7, 8. Oh, I'm so tired. 9, 10. 11 and 12. Awesome. Okay, stretch up high over your head. It feels great. So good. All right, and then stretch over to the one side and over to the other side. Awesome. Okay, now turn to your neighbor and thank them for coming. Awesome. All right. Cool. So now that you know your neighbor, because I'm sure you didn't already, you should have no problem talking with each other during the exercises or having asking for help or whatever. So yeah, great. I need to give some special shout outs. Again, Aaron Frost and Axel Rashmar were the originators of this workshop repo. I'm pretty sure that we will not, all of the stuff we're talking about today is original to my workshop, but they got the whole thing started, so thank you to them. Luke Hoban created ES6 features repo. Several of the examples use that. And Sebastian McKenzie for Babel. I should add Henry Zhu and Logan and a bunch of other people who are maintaining Babel now. But yeah, most of this stuff, actually these days now you can use most of this stuff natively in like Node 6 and stuff, but lots of this stuff wouldn't be possible without their work, so thank you to them. Yeah, we already did that activity, so great. So again, some of this will be review for some of you, but just to make sure we all have a good understanding and good expectations. I'm not going to demo every single feature of ES6. I try to stay more practical. For this part of the workshop, though, some of these things, like I said, will not be entirely like. You won't be able to just go to work and start using these, especially things like, well, unless you're transpiling, in which case, pretty sure everything you can use. So I'm not an avid spec reader. I feel like I understand how these features work really well, but there could be some things that I get wrong. So if you know better, raise your hand and let me know. But pretty sure that everything I'm going to talk about is true. So. Yeah, and we're also not going to talk about how to add this to your project at work because it's like all of our projects are pretty different. We might actually have some time to do that a little bit. I'll talk about the tooling because we probably will have a little bit more time today. And this is a very hands-on workshop. So yeah, hopefully most of this stuff will be practical. I have been using ES6 for a long time, so I do know a thing or two about it. And this is ES6 and beyond, so we'll talk about ES2016 and ES2017. Maybe I'll talk about the naming as well before we get started. That'd be good. Yeah, and it's going to be fun. Good stuff. Okay, so actually, before we get into that, I'll give you a little bit of background, because I don't think last time I talked about ES6, ES2016, ES2017, what this stuff is. So PayPal is a member of a committee called the TC39, and that is a technical committee that's responsible for JavaScript. Yeah, Denver. So yeah, TC39 responsible for JavaScript. All the new features and everything go through TC39, and then what the output of the TC39 of the deliverable is the EcmaScript spec. So there's a little bit of a history why it's called EcmaScript spec, not the JavaScript spec. It has to do with like trademarks and copyright and stuff. It's kind of silly, but basically, EcmaScript is the specification upon which browser vendors and runtime implementers will implement JavaScript. So the spec is what says what the await keyword means or what the import keyword does and that kind of thing. So long ago, each version of JavaScript, each version of this spec was called ES and then the version number. So ES 1, 2, 3. We kind of did a leapfrog over 4 because that was a bit of a failure. And then there was ES5 for a while, and then 5.1. And that was the last one we had for a really long time. I shouldn't just say really long time. I should really know. I think it's like 10 years or something like that. Until finally a group got together, TC39 again, and said, okay, let's take the things that we wanted for ES4 and trim down to the things that we're all in agreement on. And that became ES6, and it was this huge thing, lots and lots of features, and like 99% of it is implemented in modern browsers and runtimes. So that's pretty cool. But when around that time it was decided that we wanted to focus on making sure that JavaScript could evolve with the use cases that it was being used for. And so it was decided that there would be a yearly release of the specification. So bi-monthly meetings of the TC39 would talk about different proposals and ideas, and then those proposals go through a staging process to ultimately become part of the EcmaScript spec. And that staging process is it goes from the numbers 0 through 4. So stage 0 is like, this is just an idea. Should we actually spend time working on this? And if it's decided unanimously that we should, then it's stage 1. And that's when we start creating like more specifics around how the feature will work and the semantics of it, how it interacts with other features. And then stage 2 is when I think that's like when browser vendors or like when you need to have an actual like really solid specification for that feature. And then stage 3 is when browser vendors, runtime environments start implementing it. And I think by stage 3 you need to have at least 2 implementers having implemented it behind feature flags or whatever, but it needs to be implemented in a runtime somewhere. And that's a really valuable area to get feedback from runtimes to be like, oh wow, like we cannot make this performance, and in fact it's going to slow performance of other features. We can't do this, pull the plug, or potentially get feedback to actually make it faster, change the semantics or the syntax or something. And that's happened a couple times. And so then there's stage 4, and that's when vendors are like, yeah, okay, you can implement this, and it's going to go on the next release train. And so the stages or the features in stage 4 or the next version of the language will be ratified in the January meeting, and then like actually finished or considered finished in like June or something like that, I think. So anyway, that's kind of how it works. And so every single year is now, the version is now associated to the year that the features were released in. So before we had ES6, and then the next version after that was released in 2016. So that's ES2016. There were 2 features released in that, and we'll talk about both of them. And then ES2017, there were like 4 or something like that. And we'll talk about those as well. So most of the future features will not be as extensive as ES6. I shouldn't say most, I should say all, because ES6 is enormous. So yeah, that's kind of how the staging feature or the features get into JavaScript, or changes happen in JavaScript. Does anybody have questions about that? Okay, cool. So I should probably check the chat. So if anybody is online, the chat is gitter.im/kitsydots/ES6workshop. Or if anybody here doesn't want to like shout out something, you can chat in there, and I'll look there a couple. Something. Sweet. So, oh, and I should mention also that there's a really, really strong feeling around backward compatibility with the TC39. So it is really, really difficult to convince everybody on the TC39 that it's okay to make a breaking change, because a breaking change to the language will break the web, and that's something that like is the mantra: don't break the web. It's like, don't be evil. So yeah, you can rest assured, like with fairly good confidence, especially if you're just doing normal JavaScript-y things, not weird esoteric stuff, that your stuff will continue to work even as the language evolves. Cool. Okay, so the way that things are going to work, we're going to go through a quiz sort of thing, experience together, and we'll just learn about it from that perspective. We'll talk about it, answer questions, and then you'll have a test that is a test file that you're responsible to make pass by using these features, and we'll keep doing this until we're done. Some of these, there will be a little bit of an exception to how we do things, but yeah, let's go ahead and get started. If you have already set this up, then you probably, like, unless you set it up like last night, really, really late, or this morning, you probably are going to want to set it up again. So hopefully, especially if you're using Yarn, hopefully it'll be really fast. But yeah, you'll want to set this project up. And if you just go to the repo, and you can actually go to git.io/ES6workshop, and that'll go to the repo. And the setup instructions are in there. So I'll wait for a second for you all to get there. And we'll talk a little bit more about some more how things are going to work in the workshop. Okay, cool. So we go to the ES6 workshop. In the other directory, there's this workshop info thing that we'll go through really quick. So yeah, pre-quizzes, tests, elaboration, and feedback form. So these are kind of the things that you'll do for each feature. Elaboration, I actually combined with the feedback form. So if you were here last time, I had you like type out a couple things at the bottom of the file. Now it's actually part of the feedback form. And so, yeah, and there's also a test that says you actually filled that out, because this is a really critical part to your remembering the things that we're talking about. Last time, somebody left feedback that they forgot what the temporal dead zone was. And that's probably my fault. I should make it a little bit more clear or give more resources or something. But that elaboration piece where you say, here are some of the core concepts that we learned, if you fill that in, you will remember things like that much better. So yeah, definitely do that piece. This isn't just about me getting feedback. Cool, so communication. Please raise your hand and make well-meaning comments. There's the group chat, so that's linked here. It is Kenzie.'s ES6 workshop on Gitter. You can also chat individually with me. I forgot to bring my laptop, so I will use my phone to look at your one-on-one chats. So if you have any questions that you don't want everybody to know about or something, feel free to do that. I'm happy to do that. Please fill out the surveys. If you have any questions for me that are related or not, or you don't want to distract from the rest of the workshop or something, you can go to my AMA and ask those, and feel free to tweet at me. Another thing that we're going to do for this workshop is notes. So it was mentioned to me in feedback last time that I mentioned a lot of links as we go, just like random resources and stuff. And that is true. And I would love to have a place that has all the resources I've ever mentioned, but that's like not really easy. So instead, I created this Google Doc that I will paste in the chat right now. Oh, except I haven't shared it with anybody, so let me make that public really quick. Anyone with the link can edit. Okay. Cool. So you should be able to open that up and edit that. So this actually, like, some people really learn well by taking notes and stuff. So if you want to take notes like collaboratively, that would be awesome. Any links that I mentioned, you can paste in there, and I'll try to remember to paste stuff in there too. Yeah, looks like somebody got it, so that's good. Okay. Any other questions before we move on to the next bit? Okay, so the workshop repo is here. And actually, you know what I should do? I'm going to go to my desktop and I will go through the setup instructions myself. So we're all on the same page. So one other thing that I'm going to show you how to do is the running the test, because Jest was updated since our last time, and it has this really cool new feature that you should probably know about for its watch mode. It is just constantly amazes me at how awesome it is. So yeah, actually I have it written out in the README, so we can talk about it. No, I'll just show you. It'll just be a sec. I'll show you right here. So if you are running all of these tests here, you're working exercises and you're like, okay, I'm working on the promises test, then you can run yarn run or npm run test watch, and that will run just in watch mode, and it only runs the files that were changed since your last commit if you type the O key, and by default that is actually what runs already. So if we save a change to that promises test file, then it's going to run that. All the things will blow up. And it can be kind of annoying, especially if there are a bunch of tests in this file that are blowing up and you want to have like only run one test. So it used to be that you'd go in here and you'd say .only, and you can still do that if you want to on the test function itself. But there's an even cooler way with the new updates. If you look at the watch usage docs right here, it explains it. If you press T, you can filter out test name by regex. So here we see should resolve is the test name. If I hit T and I type should resolve, then I get even like this really cool autocomplete for everything, all the test suites that match. So cool. And then I just hit enter and it looks like it picked up a couple of tests. That's weird. Oh yeah, because that's a summary of all the failing tests, and there was just one. Okay, yeah. So anyway, that could be helpful to you also if you want to do that. The T will run like specific tests by their name, and P you can have it run a specific test by its file name. So immersive watch mode, read these instructions, and you will benefit. Okay, sweet. So any other questions? Okay. So I've got to close this. Sorry. And I'll close this. Okay. So normally I'm really good at checking before, but can everybody see the code on my screen? Okay, from the back? Oh, what? No, you know what? Oh my goodness, been doing that? Oh, I see, yeah. just because it is dark. Yeah, sorry, let me change my theme. Yeah, here, let's take a look. I could probably bump the font size too. Let's do that. We'll do 24. How's that? Is that all right? Sorry, I normally do that before, so I apologize for that. Okay, cool. We'll just enjoy the dark here. We've got a nice window back there, so natural light's good. Okay, cool. So I do have this this thing in quizzes. Another note: you are not supposed to, or you don't have to run the quizzes. I'm not going to show you how to run the quizzes. That is not relevant to your learning. So I think that was a point of confusion last time. So yeah, let's jump into promises. I'm actually not going to use the quiz to teach about promises because last time that really blew up and it wasn't very helpful, and we also didn't have a whole lot of time. So I'm going to start out by talking about the why of promises, and then I'm going to show you this really amazing visualization for promises that will teach it much better than just the code. So here's the why for promises. It is this function right here, and this function. So the traditional callback style for JavaScript is great. Like callback is functions are first-class citizens in JavaScript, and so you can pass them around, you can invoke them whenever you like, whatever you want to do. It's really awesome. But as things get to be a little bit nested, things get to be really hard. So you have to handle, okay, I need to handle the failure cases. I need to be able to share state between these different functions, so I can't just break them out into different things. There are things you can do to clean up callbacks, but it can get really complicated. And this thing is called the Pyramid of Doom, or it has a lot of names, but you can nest these a million ways, like get the user, then get their post, then get those comments, and then get that, and that, and that, and that, and that, and that. And it's just I don't even know. It's a terrible experience. So promises are a way that you can get around this this issue of managing state between callbacks and chaining, do this, then this, then this, right? Okay, and that looks like this, and we'll look at it in a visualization tool called promises. So let's see. I will copy and paste this into our chat so anybody can look at that. And somebody should paste it in there. It'll be okay. So this is promises. It's created by Bivakwa. He's the creator of Ponyfoo. He's a really, really great person. Basically this tool, you'll have code on the left side and then the promises chain on the right side. So if we look at just this basic example, it's using the fetch API, and this code is actually run. So this fetch API thing, it is actually making a call to /foo. If you look at the network, and we'll go run that. It is making a call to /foo. So it's failing because there is no /foo, but all of this code is actually run. So there are console errors, console logs. You can see those in here. If there's an error thrown, you'll see that in your console. So yeah, there are a lot of aspects to promises, and I kind of just touched on fetch. Fetch is a new feature available in browsers. So it's not like JavaScript feature. It's a browser feature. W3C, I guess, but it allows you to make XHR requests, but it uses promises to do that. So I think it's only available in the latest version or two of browsers. but it returns a promise, and so that's why we can use it in this context here. So let me just get rid of some of this stuff to make things a little bit more simple. And I will do console.log. Okay, so here if we look at that console log, we're going to get a response, and that doesn't really matter necessarily what this actually is. What we're mostly interested in is the relationship that we have over here. So, great. Sorry, one other thing, we'll just look at this. We console.log that p, I'm going to rename it to promise. Pop open our DevTools here. We're going to see, let's rerun that. We're going to see this S thing, which I should bump this up and go. Okay, this S thing is, it's actually kind of overloaded because we're on this page. So let me just show you before this. That S thing is a new promise. So we'll say var S equals new promise. Okay, so S is a promise, and a promise has a promise status and a promise value. We'll look at that in a little bit. On the prototype of promise, you have a couple of things on it. You have a then, which allows you to chain things off of the original promise. And by that I mean the promise can go off and do something, and like in a asynchronous way. And then when that asynchronous stuff is finished, it calls the thing that you passed to then. So that made like not a whole lot of sense, but let's look at what's actually happening here. So we'll say promise.then, and we'll pass it a function, and this is going to accept a response. And we'll console.log that response. What is happening here? Yeah, spell it correctly. And we can see that response. Well, I keep on doing it wrong. See that response here, it has the headers. The status is 404. So the request actually failed. Actually, this is kind of a bad idea. Let me pull over my timeout implementation here. We'll actually look at the implementation a little bit later because it is instructive. But instead of this fetch thing, we're going to do timeout after 1 second. Hide that down there. Okay, sorry. It's a little bit better. So this timeout function is returning a promise. I'll show you how that works a little bit later. But after 1,000 milliseconds, it's going to do what we call resolve. The promise will resolve, and our then handler, our success handler, will be called with whatever it was resolved with. So that is really bad. Let's turn off Babel. Fine. That's better. Okay, so this is kind of the chaining behavior here. Is we start with a new promise, and then we call then on it. If we go back to the beginning and we step through this, we can see what's happening at each step in our code, which is actually super cool. So we start out with a blank new promise, then we hit the next thing that happens, and that promise has then attached to it. And then that promise gets resolved or fulfilled, and when it gets fulfilled, our then function is called. So let's go ahead and attach a couple more then functions here. We go back. So we call new, or we make a new promise, we call then on it, we call then on that, we call then on that, and then on that. And then it gets resolved, then it calls our then function, it calls our next then, and then our next then. Okay, so let's do something else that's interesting. So what you might notice here is that we're doing this chaining thing. What's happening here is that it's returning, each call to then returns a brand new promise. So we could actually say var p2 equals promise then, we'll get rid of that. And then we could say p2.then, here, and I'm going to make a new function called getLog message this will return a function that takes the response, and it console.logs our message and the response, and then returns the response. Okay, so now we can just say get log with p2, and that will return us a handler. Does that make sense, or should I just like do things a little different? No? Okay. Okay, cool. So this actually is going to return us another promise. So we could say p3 dot then get log p3, and we can chain on forever like that. So p3 could return p4, but instead what you'll often see is people just chain off of the same thing, and that is totally functionally equivalent to what we had before. So the key piece that I want to relate to you about this is that what if we were to say, and we'll name this P1 just to keep things consistent. So what if instead of P2.then we said P1 right here and P1 right here? That changes things considerably. And this is like a piece of, I don't know, like something that once you get this, it really helps understand how promises work. But promises are not like a sequence of then functions. It's actually a tree. So a single promise can have any number of success and error handlers on it. And that's represented by this tree structure here. So this one promise called P1 that we created by creating a new promise, that has 3 different handlers or success handlers on it. Does that make sense? Okay, sweet. So that's a really important piece to things. Yeah. Yes, very good. Thank you for bringing that up. So we'll step through it again. We create new, and then we call then on it. That's this first one. We call then on the same promise again on P1 on that one, and then another then right there. And then when that's resolved, they'll be called in sequence, but it'll like happen in the same loop. So sorry. Sorry. That's correct. Yeah. And yeah, so it pretty much never here. In fact, if we were to change this, whoa, why can I not? There we go. So if we were to change this to never actually resolve, then these will just stay unresolved forever. So your functions will never ever be called. Or like if it alternatively, if it takes a really long time for them to resolve, they'll just sit. But like if you have like, and I've had this before, where you have a node program or or a node script or something, and you wind up adding a handler on a promise that never resolves, your process will not exit. So it does wait for that promise to resolve. So sweet, good question. So let's say, so the second argument to this timeout function is this should reject thing, and I'll show you later how that stuff works. But let's see what happens if a promise fails or rejects. So you make a asynchronous request to some server and things go awry, you get a 500 back or something. So here, oh, whoops, not fail. Let's say var should fail equals true, just to be clear. So it fails after a second. So now everything is red, it's all rejected. And if we look at our console, we should be seeing a couple console logs, but we don't. We see no console logs, nothing was logged. And the reason for that is because unlike callbacks where you have a single callback, let's see, yeah, single callback, this thing, that accepts an error and a result. Promises, you use 2 totally separate code paths, 2 totally separate functions to handle errors and successes. And that you can do as the second argument to then. So the first argument being this response thing. Here I'll say get log P1. And then the second argument is the error handler. So we'll say error, and we'll console.log that error, or we'll console.error, the error. If we look at that, it's rejected after 1,000 milliseconds. So, yeah, and that's pretty much it. You'll notice the interesting thing here, though, is that the other two promises still rejected. Or the other two, yeah, the other two promises were, like, we didn't recover from the error. However, in this one we did. And so if I were to actually take P2 now and add a then on that, and we'll get log P2 1, I guess. I don't know, doesn't matter. That promise chain actually changed from rejected to fulfilled or resolved. And from there on, I can chain stuff as much as I like, and that whole chain is going to be all fulfilled. So that's an important piece of the promise puzzle as well, is that you can take the state of the promise and, well, okay, so I should be clear. Promises, there are 4 promises on this page right now. Every single call to then creates a brand new promise. But if you think of a chain on the promise as having some sort of state associated with it, you can change that state from resolved to rejected and back again. And we're doing that by providing an error handler and then not really, like, basically handling it. So your next question might be, well, okay, so what if I want to just log it and then I want it to remain in an errored state? I want all the extra thens on it to be errors. So we'll do then get log to success, and we'll do get log p to failure. Okay, so it's not in a success state. We want it, or it's in a success state. We want it to go back to being rejected. So the way that you accomplish this is based on what you return or what happens in your handler, in your error handler. So if we throw that error, so we'll log it and then we'll throw it. Oh, whoops, this is messing things up. We'll just comment that out for a sec. So if you throw an error from your error handler, then that keeps it in a rejected state. That makes sense? Okay. The other thing that you can do, rather than just throwing an error, is you can return promise.reject. That will do the same thing. Keep it in an error state. We'll talk about promise.reject a little bit later in more depth. But that's the only way that you can cause a promise to go to a rejected state, is by returning promise.reject or throwing an error. The same thing applies in a then handler. So if we change this, or should fail, to false, everything's going to be green. But let's add a p1.then. Maybe we should clean some of this stuff up. We'll add a success handler. Yeah, okay. And inside this success handler, let's return success dot A, B, C, D. Okay, so what's going to happen is it fails because it can't get A, B, C, D. That it doesn't exist. Undefined issues there. So when there's an error, whether it be like getting a property or any kind of runtime error inside of your success handler, that changes it to a rejected state as well. Any questions about that? Yes. Yes, we're using .catch in the mapping. Oh, yeah. Sorry, that's, yeah. Thanks, Nick, for that. Yeah, so that's actually perfect. A perfect segue into the next thing that I wanted to talk about. So there's a shorthand for, or not a shorthand, but there's another way to add an error handler to a promise. So if on here I say .catch and then error, then I actually can change it back to fulfilled because I'm not doing anything with that error. I'm not returning or throwing or anything like that. So that's a way to catch the error, change it back to a resolved state. A really important, and basically this is equivalent, functionally equivalent to then null error. So if you don't pass the success handler, your error handler will be basically the same as catch. Okay, so important piece to this puzzle, and something that I see often is confusing, is let's say you're just like, I don't want to add another catch, I'll just add a second argument to this then function to be my error handler for anything that happens in here. Well, that doesn't work. So the error handler right here can only handle errors for the promise that you are calling then on. So it won't handle errors to its sibling success handler. Only the ones you're adding right there. So often, if you're doing a bunch of things all at once and you want to handle all of those errors the same, like it doesn't matter which one blows up, you don't care, you just want to say, oh, okay, that was an error, that whatever, then you could chain a bunch of promises after one another. So we'll actually do that. We'll say p1 dot then get log. Whoa, things are getting too big. And then you can just add a catch at the very bottom, and that will handle all of the errors anywhere in this place. So here, if I were to, in my get log, throw a thing to, wow, this is, I wish there were a way to, okay, let me just fix this thing really quick. So I'm adding an API into this get log function to throw, or we'll return promise.reject response. So that'll change it into a failure state if I say true here. Okay, cool. So here on P1 we have this then, and then the second then actually is going to return promise.reject, changing it into a rejected state. And because we have a catch at the bottom of this promise chain, that catch is going to handle it, and it changes it back to a fulfilled state because we're not doing anything. But we could keep it in a rejected state by throwing or promise.reject or something. That makes sense? Okay. Mm-hmm. How do you keep this one? Yeah. So that's a good question. If you want to make sure that you just handle the one error and then everything else continues, then what you could do instead of just doing this promise chaining stuff is you could actually say var p5, do that, and then p5 dot or here, p1 dot then handle the rest of these things. And so on p5 you could say p5 dot catch, and then that's a whole different tree all the way down. So that's kind of like one of the values of understanding that this whole promise chain thing is really actually a tree, because at any point you could say, okay, I'm going to take that promise, I'm going to branch it off to this other thing that I'm going to handle things differently, and then we could totally, actually here we'll turn this one into a failure case and turn this one into success. And so here we have this, boy, it's really confusing with all these other promises. Sorry. There we go. So we only have one chain. So here we have this promise we call, I don't even know which one. Yeah, this one. Here, and we'll say, leave that one in an error state. That's so funny. I have no idea what. Oh, haha. There we go. Something's wrong. Oh, no comma. There we go. Okay, there we go. That's better. So here, and if we go back, we'll step through this. That might be helpful. So we create that promise with that timeout thing. We call then on it to do this get log. This then is going to fail. And then on that we call catch. And then we create a new chain, still off of the original P1, starting with that then. Off of that we add another then, and then another, and what just happened here? Go back. So we have 3 thens. We still have those 3 thens, and then we have a catch. Oh, that was that right there. That's better. This tool is really handy. Okay, and then we have those other 3 thens, and then this promise is fulfilled. So should fail is false. But we on our first handler here, we say that should fail, and so we create a new promise with that promise.reject stuff right there. And that rejects, and that's returned by our first then right here with this get log. Before our catch is called, because actually this is a really important piece to promises as well, is that promises are always asynchronous, all the time. You will never have a promise that is synchronous. And so what that means is things will happen on the next tick of the event loop. So there are benefits to this, but there are some really sad things to this as well, which we can discuss at length later if you like. So that's why when we created this rejected promise and this then returned that and it turned into a rejected state, this catch won't run until everything else is done. Okay, so we've already queued up these other thens. So we'll say, yeah, basically run through those. This then, what just happened? Created the new. Hold on a second. All this stuff that I just told you is totally a lie. So yeah, the promises are always asynchronous, but I'd have to look in or think about things a little bit more to figure out why that catch was happening when it was. Oh, sorry. So yes, it's true. All promises are asynchronous, including every single one returned by these. So every single time you say then, next event loop, next event loop, next event loop. And that applies to these as well as the catch. That's why, sorry. Does that make sense? That may have been a little confusing. Okay. Yeah. So all promises are asynchronous. That means they resolve or reject on the next tick of the event loop. How many people are familiar with the event loop in JavaScript? Okay, a little refresher course. So when, there are actually some really great talks about this. I'm trying to remember. Let me just see if I can Google it really quick for you. JavaScript event loop video. This guy, yep, Philip Roberts. This is a really good talk. And I'm focusing right now, so let me unfocus. Disable that. Okay, so yeah, super talk. It goes really in depth, so I recommend you look at that. But the event loop, basically, as you're making calls into functions, that adds things on it. Well, okay, that's talking about the stack, and that's a little bit more than what we need. So JavaScript has an event loop where it runs your code like synchronously, and then when it's all finished, it just kind of waits for the next thing to happen. So it's not running any code, it's just kind of waiting for a button to be clicked or a promise to be resolved or XHR to be to come back. So some callback to be called, and that starts the next tick of the event loop. It goes through all of your code again synchronously, and it does this forever and ever and ever. And so with promise, and actually, like you can kind of simulate the event loop with a set timeout. This will happen on the next tick of the event loop. So that's why you can say console log first and console.log second, and you'll see that first comes before second, even though it comes after in the code linearly. And so that what's happening here is you're adding this callback to the event loop. Now that's we can say const callback and assign that here, and we could say do callback right there, and we invoke it, and now second comes before first, right? So the fact that it's inside of a function means nothing. It's the fact that it happens at a later time. That goes on to the next tick of the event loop. So every single time it says, hey, what new work do I have to do? Have these promises been resolved? Have these callbacks been called? Whatever needs to happen, then I'll run all of that code and go through the event loop. So with promises, every single time you create a new promise and resolve it, or promise.reject or anything, it all happens on the next tick of the event loop. Which is why if I were to say my timeout is 0, so 0 milliseconds, and I go back to the start, I create that new promise, I add the then, even though this presumably should have resolved already, right? But it is always asynchronous on the next tick. So all of this setup happens beforehand, running synchronously. And then with each tick of the event loop, this promise is rejected. That promise is handled. We reject the next thing, and that gets caught, and so on and so forth. Does that help clarify things a little bit? So promises always asynchronous. Yeah.
So all the then be like so maybe after first time.
Yeah, on any single branch of the tree, it will always follow that sequence. Yep. And if you're putting another then on an existing promise, so you have two thens and you're branching off, it's whichever one was added first. And then the next one will be called within the same event. Okay. Cool. Let's see what else there was. Yeah, I think that was it for this piece. So yeah, if you wanted to take a branch and say, okay, this branch or this request doesn't matter a whole lot, so let's handle that edge case and we'll resolve that. But all these other things, we want to catch all of those errors the same, so we'll just then all of those and then have a catch at the end. Cool. Sweet, so we're not done. Let me just review really quick. I have a list of things I wanted to make sure I covered. Oh yeah. So we talked briefly about this, but there are 3 states to a promise. So there is the pending state. This promise is currently pending. So like something's happening, it hasn't resolved quite yet. And then there is, and we've seen this, there's the resolved or fulfilled or resolved state, and then the rejected state. So important piece. So that promise can be pending. I think we did talk about that already. So just want to make sure I cut it down. Yeah. Okay. We talked about promise, reject, and resolve just a little bit. So let's talk a little bit further about what you can do with reject and resolve. So let's go ahead and I'll console.log promise.resolve. And we'll just count that out. So that actually creates a new promise for us. And this promise, oh goodness, sorry. It's kind of funny with what he does in that page. So promise.resolve has now a promise status of resolved. So if we did a new promise, we'll look at how to create new promises later. The promise status will be pending. And this in particular, this promise will always be pending forever because we have no mechanism to resolve it. But yeah, when you say promise.resolve resolved, just call it with promise resolve, it starts in a resolved state, it will always be in a resolved state. We can give it some data, and if we look at the promise value, these are, by the way, these are things that you can't really get off of promises directly. Like I couldn't say promise.resolve give me a promise status. That doesn't work. Okay. So these are just things that Chrome is being really nice and showing us. Yeah, our promise value has this data object that we pass to it, so you can resolve with some data. Going back again to the fact that promises will always be asynchronous, we can say promise.resolve with hi. We can call then, bump that up a little bit, with result. We'll console.log the result. And then here we'll console.log hey. So hey comes first. Promises always asynchronous. Every single time you call then, that's going to happen on the next tick of the event loop. But the cool thing about promise.resolve is it allows us to create a new promise and start a new promise chain. So I have seen and written code that looks like this. Like then get thing, then get other thing. And we'll talk a little bit more about that. But like this would presumably be a function that returns something valuable, and then this returns something else valuable. You can almost think of then as an array map, where like we call all the items on this thing and it returns us something, and then that's the thing that we now have. Yeah, so you can start a promise chain off with resolve if that's something you really wanted to do. Yeah, promise resolve and promise reject will become more useful when I teach you this next thing about promises, and that is that promises are chained in such a way that what you so you add success and error handlers. What you return from those things are passed to the next promise. So to actually, instead of visualizing this, I think it would be more instructive to do an example. So we'll do, yeah, we'll run these quizzes right here, and I'll just put it up here. Hold on a sec. Go. Okay. So I'm going to make a P1 is a new or promise.resolve. So I created a new promise here, and then P1.then result. We'll console or we'll log the result. Okay. So duplicate declaration of log. Where's use me. Okay. So here we're seeing that the result is undefined. And that's because we didn't resolve our promise with anything. So we'll resolve it with the string hello. And now when we say p.then, the result that we get is what the last, or the promise that we're chaining onto was resolved with. So now if I say then result, so on this, for this result, we'll just do the exact same thing. Who wants to guess what this second log will log out? Yes, undefined. Because the promise that we're chaining off of is not P1. The promise we're chaining off of is the one that's returned from this then. And there's nothing returned from this then handler. And so it gives us undefined. So if we were to return the result, then we're going to get hello and hello. We could return anything that we want. Okay, another interesting fact of this is you can return anything that you want to, but if you return a thenable or a promise, something that you can call then on, then the promise chain will wait for that to resolve. So a practical example of this would be like, let's say this promise is getting a user, and then we want to return here. So we'll get, when that resolves, we'll get the user, and then we could say user.getPosts, That get post is going to return us a promise, which will resolve with the post. So this is a great use case for something like that. So let's see that in action. We'll say new promise, and I promise, that we will get to the promise constructor. Just you'll see this in a second. So we're going to do something after 500 milliseconds, and then we'll resolve with there. So here, and we'll do 1500 milliseconds. So you see hello, and then you see hey there. Okay. So if you return a promise, it will wait to call any things chained off of it until that promise has been resolved. Okay, cool. So here we can, yeah.
Yeah, we want the do and the running it. How is that we do with that question? If we do not done,
Yeah. So,
we just return that.
yeah, I see what you're saying. So what P2 is actually being assigned to is this last call to Ben. That makes sense?
If we don't have it,
So if we didn't have that call, then it actually would be assigned to the promise that gets resolved, or to the promise that gets returned from this. So and this promise will resolve to a string called anything, but a call to the .then will always return a promise. And it will resolve to whatever is returned from this. Okay, sweet. Moving right along. Okay, so let's say what would happen if I throw a new error here. So what's going to happen in this case? Yeah, so this won't actually run, and actually we're going to get an unhandled promise rejection warning. So this is actually really nice. When promises were initially implemented in Node and browsers, promises would swallow your errors. You would never see any kind of logging of any kind. Now Node and browsers will throw an error or logs, throw an error that is an unhandled promise rejection error, which is pretty cool. It's nice. Yes.
so still consider but
It is actually it's rejected. Yeah. So because the rejected promise isn't handled by a catch or something like that, then and that's why you get this error. So yeah, you must handle all of your errors, otherwise you'll get this error thrown. So you mean if Yep. That's right. Yeah. Yep. Yeah. So if let's make that more clear. Log. Hey there. Really clear. Yeah. So we won't see that. Yeah. In this case, it's Node, but yeah. So actually, here, we'll just toss this in a browser really quick. We'll get the same thing. Uncaught and promise. Oh, haha. No, that's something totally different. It's basically the same kind of thing. Here, we'll make it console.log. There we go. And what? It's the same thing. I don't know. I don't want to dive into why that's happening. Okay, cool. So if we wanted to handle this error here, then what would we do? There are a couple of solutions to the problem. Catch, or what was the other thing? Error. Right there. Could I put an error handler here? Yeah, that handles P1's error. So it would handle if I did reject, but it won't handle any errors inside of its sibling success handler. Cool. So if instead, oh, let's see. Let's actually do promise.reject now. So this P1, and we'll turn these back into our handy logs. So what's going to happen in this case with this rejected promise? Yeah, so we're not handling any errors of any kind. Like we all just said, we could add a catch or add a second argument to this. And now in this case, we can add a second argument, right? Because we want to handle P1, P1's error. So I'll add an error handler here. And we'll console that error, or here we'll just log the error. Okay, so that error being this hello thing. And that's turning the promise back into a resolved state, right? Because we're not rejecting, throwing, or anything. Yeah. Yeah, it's not. That is a good question. I'm trying to remember if it actually will pull down like your node service or something. I don't think that it would actually crash a node server. I'm trying to remember. I don't think that it would. Maybe during the exercises I'll test that out, but I'm pretty sure it wouldn't do that. Good question. I do know that you can globally handle unhandled promise rejections, just like you can globally handle regular node errors and stuff. So maybe I'll find that in the docs and put that in our documentation stuff. So no, it would be. I'll go look it up in the docs, and I'll show you how to do that. Yeah. Cool. Okay. So, like I said earlier, if we wanted to continue this promise to be in a rejected state, then we could return, or we could just rethrow the error. So we've logged it, and then we rethrow it, and so we'll get hello, and then the unhandled promise rejection, or we can return promise.reject the error. Okay, so let's go back to the browser here really quick, and let's look at var x equals promise.reject. Promise. Okay. So if we look at the value here of promise of this x promise, the promise status is rejected, and the value is hey. So promise.reject and promise resolve, very similar. They just construct a promise that's already in any given state. But again, chaining anything off of those will always be asynchronous. But because of the way that promises work in these error handlers, when you return a rejected promise from an error handler, then that will continue in a rejected state. Now, there's a slight difference, however, between resolve and reject. Here, let's go user. So with resolve, you can actually, just like inside of this then function, how we could return a promise and it wouldn't call the next then until that promise resolved. With promise resolve, you can actually do the same thing. So if we, oh goodness, do I have the, I'm going to move this timeout function here. Okay, so we have that good old timeout function again. That timeout function is going to return us a promise that will resolve in 1 second. So you can actually pass promise resolve a promise that is in pending state or resolved state, or even rejected state, I think. And the promise that's returned from promise resolve won't be resolved or rejected until that promise is resolved or rejected. So we can see that here, resolved after 1,000 milliseconds. That contrasts, however, with promise.reject. So promise reject, you pass it anything, and that is what it will reject with. That is the value. So we just rejected we just created a new promise that has a rejected state, that where its value is a promise object. So important distinction to know there. I can't think of a use case where you'd want to do promise.reject. Here's a promise. If you want to be able to like handle a promise that will reject or something like that, then all you do is resolve, and then here we'll say this will reject, and it will be rejected after 1,000 milliseconds. And that actually is coming from here, so hey there. So hey there, rejected after 1,000. Okay, cool. I promise that we will get to like your hands-on stuff, but promises are a pretty big subject, so I want to cover all the angles. Let me make sure that I'm getting to where things are going. So yeah, again, if anything that you return from an error handler, that changes the promise to, or that makes the promise be resolved. You must throw or return promise reject, and anything you pass to promise reject is the value itself. If you return if you pass a promise to promise resolve, then that promise assumes the state of the promise you give it. Okay, we talked about an error and success handler, non-error, and yeah, recovering from a promise, or from a rejection. I think that we pretty much covered all of that stuff. So anybody have any questions before we go into the tests? Okay, sweet. I will give you, let me just look over the tests really quick. Yeah, sure. Hmm.
You explain a bit of
Yeah, that's a great question. So the question is, when should you use promise resolve? When should you use promise reject?
right.
Yeah, and I think probably the reason you're asking that question is because I forgot to talk about the promise constructor. Because normally you'll actually just use the promise constructor if you want to create a new promise. But pretty much the only time I use promise reject is to handle errors like this. I generally, I just don't like the way the word throw looks in my code. I don't know, it's just a weird thing about me. And so I prefer promise reject. And yeah, I often don't really use promise resolve unless I want to kick off a promise chain and I don't really care about things happening on the next tick or something. But yeah, let's look at the promise constructor. That will be helpful. So we're going to build this timeout function here. So we'll say function timeout. That's going to take a delay. That'll default to 0 milliseconds. And a should reject. That'll default to false. Okay, and I'm going to go ahead and delete the actual implementation down here so we don't have problems. Okay, so we have this. What we're going to do is do just like a normal set timeout. Set timeout. And we'll have a function here that we want to do something in there after the delay. But we need to return something, right? In fact, we need to return a promise. So if we go back here, this P1 needs to be a promise. So we're going to construct one. And I should say that this is something you will not often do. And in our applications, like our node layer, we use, because like most of our node stuff is using callback pattern, right? And we want to use promises, and when we talk about next, we're going to talk about async await, which is like even more awesome for many use cases. But we want to convert all this callback style stuff that we have in Node to promise so that we can chain it and everything. And so like you can create your own promises using the promise constructor. but there's a package called ES6-promise, I think. I'll look it up and let you know for sure. But it basically converts node-style callbacks to promises for you. So you just pass it a function. Actually, I prefer Pify. Let's see, I think it's PIFY. It's the one that I use on my own stuff. So basically this PS read file, and then you call it, and yeah, converts it to to promises. Really cool. Let me just put that in. Okay, sweet. So anyway, we are going to create our own promises. So we'll return we'll just call it promise equals a new promise. And this promise constructor accepts one argument, and that's called the resolver. So we'll call it a function called resolver, and that is resolve and reject as arguments. Oops. And let's just see. Okay, so we're going to put our set timeout inside of that. And when the timeout has finished, then we're going to either resolve or reject this promise. So we're going to say if we should reject, then we'll reject with rejected after, we'll do template literal because they're the best, delay ms. Okay. Otherwise, we'll resolve. Well, we'll basically do the same except resolve. Okay. So, and then we'll want to return the promise. So the promise constructor, new promise, takes a function called the resolver function. We can turn this into an arrow function if we so please. And then we do any asynchronous thing we want in here. So if you're consuming like a node callback thing or whatever, this is where you say user.getPosts. Here's my callback, error, success, or body, or data, whatever. If there's error, then we'll reject, else we'll resolve with the data. Maybe I should have used that as the example, but I think you're following. Does that make sense? Like I said, if you have a project where you want to create new promises frequently, then it's quite likely that you could use something like Pify to do that for you. Actually, as another resource, Promise Fun by Cinderosaurus is really, really good. So this is a collection. I remember watching GitHub when he was making all of these. He has a bunch of other things for promise utilities. So you can run a bunch of things at once, you can queue things up, you can limit, you can memwise, like a whole bunch of really cool utilities that use promises. So I'll paste this in our shared notes as well. So yeah, definitely something to look at. Really, really powerful utilities. I just remembered there are two other things that I didn't show you that I want to before we get to tests. So I'm sorry. There's promises have a lot of stuff. There's actually, I'll tell you about that later. So, but before we go on, does anybody have questions about this promise constructor? I'm actually going to stop really quick. I should have been doing this as we've been going. I want you to turn to your neighbor and teach them how to construct a promise. So I'm going to go ahead and make another example of the promise constructor just to solidify things. So let's say we have this get user thing that takes user data and a callback. And here we'll say like do some async thing, and then we'll call the callback with null and stuff, whatever comes back from that request. So we make it XHR, whatever. Okay, so this is a node style callback. So if I wanted to wrap this in a function that uses a promise, then I could say pGetUser, so a promise version of getUser. That would take the user data, but it's not going to take a callback. What it's going to do instead is return a new promise that resolves or rejects, and then it's going to say get user with that user data that I got. And for me, as the promise constructor creator, I am going to pass the callback, but I'm going to accept and I'm going to accept the error and the stuff, or the user info, whatever it is. And if there's an error, then I'll reject with that error. Oops. Otherwise, I'll resolve with the stuff. Okay. And then if I wanted to consume that, it would be p get user with the user data, then handle the success, handle the error. Okay. So cool. Hopefully that's helpful. So there's two more things that I want to talk about before we go on to the exercises, and they are promise.all and promise.race. We're going to go back to this visualization. So we're what we have here is in just our example is this promise.all call, and inside of here we're passing an array where we're constructing a bunch of new promises that it's going to take our resolver and that first argument being resolved, and we'll set timeout and have them resolve after a certain number of milliseconds. So we have we do this all the time in P2P code base. Actually, we need to get the funding options, and we also need to get contacts and various things, and they're totally interdependent or not related at all. I don't care what the value of this is versus that. And so here we can have them all go at the same time, but we want to wait until they're all finished. That's the use case of promise.all. So if we're going to start over and step through things. So we create a new promise, that's this first one. Then we make another one, and then another one. And based off of these things, this is order of operation stuff here. So these lines of code ran first, and then this ran. We created a new promise with promise.all. Then we attach a then, so we've got a new promise there, and then another then, and then a catch. And then all three of these things fire off at the same time. And this all is pending, waiting for all three of these to resolve. So we get the first one, this one's still pending, the second one, and then the third, and then this all is fulfilled, it's resolved. And then the promise chain continues. It blows up because we're doing something silly, but we take care of it with this then, where we're, or with this catch, where we don't throw in. But does that make sense? That one hopefully is fairly straightforward. It's mostly you have several things. Actually, often what I've done in some of my projects, I'll have an array of files that I want to load, or I have an array of URLs that I want to fetch, and I will map those to a promise, and then promise all on that mapped array of promises. So yeah, I use map.all quite a bit. That one's pretty useful. Promise.race is probably what you're thinking. So here, if let me just be able to see everything. So here we have a P1 and a P2, and we're using promise race on each of those. And this one's kind of an interesting example, but for promise.race, the why behind that is I want the first one of these that resolves, I want that one. And if one of them fails first, I want that one. Whichever one is no longer in a pending state first. So here we have a promise that resolves after 4,000 milliseconds, and then one that rejects after 8,000 milliseconds. And then we actually put that promise race promise, which ultimately is going to resolve, into another promise.race, where we create a new promise that resolves after 6,000, another one that's after 10,000, and then one that rejects after 2,000. So this would actually be a good one to have you why not? So what do you all think or try to like figure out what the results will be. Are we going to get a console error? Will the promise be will P2 be resolved? Will P1 be resolved? What is going to happen here? So first question, P1, is that going to be resolved? Yeah. And then P2, will that be resolved? So remember, with promise.race, it's all about which one finishes first. Yeah, it will be rejected. So here, let's bump that up again. We're going to go back. We'll step through it. So we create a new promise, and that's this one. Then the second, that creates a new promise with promise race. And then we pass promise race to this other promise race, but you don't actually see that. You just created a new promise. Then we make a new one. This is the 6,000. That's the 10,000, and this is the one that's rejected after 2,000. You can actually see the code for that promise right there, which is kind of handy. And then we create a promise.race off of that. So then we attach a then on P2, and then a catch off of that as well. And then things start happening. So this new promise, this first one right here, was resolved. And then these ones get resolved, or the 6,000 and the 2,000. Yeah, this is actually kind of hard to read. What actually happens first is this one gets rejected, then this one gets resolved, then this one gets resolved, then this one, then this one. But it's kind of hard to visualize that actually. But in any case, this first rejection happens, and that puts our P2 into a rejected state. From here on out, it doesn't actually care about the other promises. And even though they do end up like resolving and everything. So including P1, these other promises, doesn't matter. So it can continue on to the promise chain, which leads to this then being rejected. So actually, maybe a little bit more useful would be to just have it all run, and then we can see the console logs. So, well, I don't know if that was useful, but yeah. Anyway, hopefully that that kind of makes sense. Basically, the idea is promise race. First one to win wins. It's a race. I don't know what more to say about that. Any questions about promise race and promise all? Yeah. So promise.all is easy to find use cases for. I have yet to find a use case for promise.race. Yeah, I know that people do use it. I'm trying to think. I feel like I've used it before for something, but I can't remember what. But yeah, it can be useful. Okay, cool. That was it. That's promises in an hour and a half. Yeah, there's a lot to promises, and you can get by just understanding then, but you can use them a lot better, more effectively if you understand the semantics to like what happens when you return from a success, or how do you change a promise chain into resolved. Okay, great. So let's finally get to the tests, and when we're done with these tests, we'll go to lunch, and then we'll do async await. Which is really cool. So, great. So your tests are in exercises 14 promises.tests. And again, inside of here, what you can do is yarn run or npm run test:watch. And then you could do p to do the promises. Yeah, just p and then type promise. That will just run this file. And your job is to, just to make these tests pass. So this will require, I should explain something about promises and jest. So jest is capable of accepting, or accepting a promise from the thing that you return. So your objective to make, like the way that you make these tests pass is you make this promise resolve. So the promise that's being returned is pick apple, and then you need to make it resolve. And here we'll look at the pick apple function here really quick. It's basically, it takes a ripeness, we create a new constructor, we set timeout that like doesn't actually have anything, but we're just doing asynchronous stuff. And if it is, if ripeness is ripe, then we resolve with ripe apple. If ripeness is unripe, then we reject with unripe apple. Otherwise, we'll reject with a new error out of apples. So when we say up here, pick apple ripe, that promise will resolve. Pick apple unripe, that promise will reject. And pick apple with nothing, that will also reject. Okay, great. Yeah, so normally, and I should have mentioned this, so normally you will want to reject or throw an error object because that's going to give you a stack trace. And so, like in our pick apples example, here we're rejecting a string. That's not going to be very useful. You should be basically the same thing that we do right here. You should reject a new error. Or if you're like in a then handler and you want to make it error out, then you'll throw a new error. Or return a new promise.reject a new error. That way you get a stack trace. And then inside of this catch, error objects have a message that you can use to compare. Okay, great. So before we begin, does anyone have any questions about promises? Okay, you know pretty much everything there is to know. One thing I didn't mention is there's a proposal for promise.finally. So adding finally to the promise prototype, and that would work just like a try-catch kind of thing. So whether or not there's an error, your finally will run. But we're not going to talk about that. That's just kind of an interesting fun fact. Okay, the next thing we're going to talk about is async await. Async await is actually been ratified in the ES2016 specification. And actually, if you want to see all of the proposals and where things land, I'll paste this in our doc. But this is the TC39 proposals repo. And here you can see the active proposals. There are plenty of things in here that are really interesting, and we'll talk about maybe some of them. There are stage 0 proposals, which are just like a gleam in someone's eye right now. And then finished proposals, which start at ES2016. So we see the 2 features there, and then there are quite a few features in ES2017. One of those is async functions, and that's what we're talking about. So this, like I said, to even get to stage, to get to stage 4, a proposal needs to have implementations in browsers, and this particular feature is actually implemented in Chrome and Firefox and Edge, I believe, maybe Safari even. So you can use async await in modern browsers, which is pretty cool. And so that's why I'm actually going to check off the Babelify thing, because I'm just going to use native promise or async await in my code here. So so let's do that. I'm going to start out. We have this timeout function that we've been getting used to. I'm going to start out with a promise. Here we're going to make a function called go. And we'll call that function go, and I'll explain why we're going to put this in a function later. But here we'll say const p1 equals timeout, and then we'll say then let's see what. I feel like I should just get a little utility here. No, I'm going to make another little utility function, get logger. So we'll give it a message. And this will return our success handler that takes the response. Return the response. So we keep the promise chain going, but we'll console.log the message and the response. And then actually we'll get error logger, and we'll return promise.reject. And instead of response, this will be error. And instead of log, it'll be error, and error, and error. Okay, cool. So I can say, and hopefully all of that is pretty straightforward now that you understand promises. So I'm gonna go ahead and say get logger p1 here, and we'll get error logger p2 error, I guess, something like that. So normal promise stuff, and if I wanted to chain something else off of that, I can chain this forever. It's great, we love it. But this code still could be a little bit cleaner. You know what? I'm going to do this instead, just to make it a little bit more clear what's going on. Instead of using these functions, we'll get the response, and we'll get the error. We'll just do inline functions right here instead. Sorry about that. So we'll console log the response, console.error, error. Okay, so we're going to do some sort of asynchronous thing, and then we're going to do something with the response. And then we want to, I don't know, we'll return the response from here, response. And then we'll add another dot then get, let's see, response. And in here we're going to say, I don't know, get things with the response. So we're building up this promise chain of things that we want to do. And it is certainly better to do, or like, as your promise chain grows, it's certainly better to do things with promises than callbacks, or at least it's a little bit more clear. You just read from top to bottom. But it's still not super clear. Or it's like, it could be better, even better. So I'm going to call this go promises. And I'm going to make a similar function that I'm going to rewrite with async await. So the idea behind async await is to allow your code to look like it's synchronous, but actually be, or it reads like it's synchronous, but it actually is asynchronous. So the first thing that's required for you to be able to use the await keyword in a function is that function needs to be an async function. So we're going to put async in front of this function. And actually, before we continue on, I'm going to show you what that does to a function. So my async, so a totally empty function, and we will just call that, and we'll console.log. And first I'll take off my async, and we'll look at that what that does. You know what, we'll do this just in the console. Be a little better. Okay, so we have this function, my async, we call it, and we get undefined back. We're not returning anything, right? If I were to stick async in front of it, now what I'm getting back is a promise. So that's a key differentiator, is no matter what, always, always, an async function will return a promise. And that promise, right here, let's take that a step further. So here, if we throw a new error, then we try to call it, it's not going to log anything, it's just going to blow up with that error. However, alternatively, if we say async in front of that, then we are gonna get an error because we didn't handle the promise. But what we are still logging out a promise that has a promise status, rejected, and a promise value, blah, at my async, which is that the value is the error that we threw. And then we get this error because the browser's like, you didn't handle that. Okay, so you will always get a promise back from an async function. Yeah? That's right. Yep. And let's see, I think if you return a promise.reject of that error, you're going to get the same thing. So, throw or return. With async await, I find it more frequently that you are actually throwing errors in async functions rather than doing anything with promise.reject. Yeah. Cool. So that's pretty interesting. So we've got this function now as an async function. We're not actually doing anything with the return value here. Maybe we'll do that in a little bit. But yeah, let's start converting this to async await. So the first thing to say about async await is async await promises like this. Async await is just syntax sugar on top of promises. You can express anything, well, not necessarily cleanly, but pretty much almost anything in promises that you can do with async await. There are a couple fancy things that we might get into that you can do with with async await that would be really hard to do with promises. But cool. So we're still gonna do this const p1 thing, but instead of all this then chaining, we're going to say await in front of timeout. And what this is kind of weird, but what this basically does is it says, oh, okay, I'm going to take that timeout and I'm going to wait for it to resolve to something. And whatever it resolves to, I'm going to assign to P1. So P1 is not a promise anymore. When you assign something to something that's awaited, it is the resolved value. So if we were to console.log P1, here, we'll do a couple stars so we know which console log we're looking at. Resolved after 0 milliseconds. Okay, so it's not a promise, it is the resolved value. So, great. If we wanted to handle the error case, so actually let's just change P1 to response now. That's what it is. So we've got that taken care of. Now to handle the error case, you have to do, well, there are a couple of things you can do, but for us, we're going to, for most cases, you'll do a try catch. And we'll put that inside of here. And then we can handle the error. And it works just like a normal error or a try catch. You would think, like, if you want to recover from it, you just don't throw anything. And if you want to like propagate the rejection, then you would throw. And as we saw earlier, an async function, when it throws, will reject the promise. And so then if you want to keep chaining things, you want to do some more stuff with the response, then you simply do more stuff with the response, just like it's regular JavaScript. And anytime you want to do something that's asynchronous, you want to do another promise-based thing, then you just put another await in front of it. So it's a const user is await get user with maybe that response was something useful or whatever. Yeah, and then we can say user.find posts. It's a const posts equals await. And if we wanted to catch all of these errors all in the same thing, then we just put them up here. And we'd say, okay, get the response. Then based on that response, get the user and wait for that. And that's the user. And then get all the posts for that user. And then right here you could say return posts. And what that will do is now, because Go is an async function, it returns a promise. If all of this passes without any trouble, then we can say, here, and actually, because of block scoping, we do this, that's better. And here we'll return null or something. So then we say posts. And if posts is null, then, I don't know, something probably better just to throw the error. And you don't have to worry about that. You'd say an error, handle the error. So async await, promises, tightly coupled. The reason that we put this in a function is because you cannot await at the root level, because there's like await needs to be inside of a function that is async. So we couldn't say await go, that doesn't work. It has to be within a function. Yes, and so like yeah, like I'm not actually sure, because like technically I could see this working where you're like await fetch foo const foo. Like if you just look at that, you're like, yeah, I don't see any reason why that wouldn't work. But the like the rules of await is that it needs to be in an async function for it to. Await itself does not turn a promise now. Await just turns a promise into like you can think of it like this. It operates in similar fashion to pretty much like most languages that will wait for like that are not async, I guess. So like in Java, you make a request to the server, that nothing else happens until that comes back, and then you execute the next line. In the same fashion, await, as it's going through the code, it stops there, stops execution. Well, at least within that function. Like the rest of the code will go, like for example, and that's actually good to bring up. So if we say console.log going, and console.log start going, then we're going to see start going and going, well, and then things blow up because we don't have get user. But this going is going to execute even if like when the go function pauses execution there. So it doesn't actually stop the JS engine or anything like that. It's still a totally asynchronous operation that's going on. But async await allows it to pause execution and then start back up again, remembering all the context of that function, all the variables you created. So ultimately the goal being, let's make it appear synchronous so that we can code like it's synchronous, but it's not. Yeah.
So when you are promise, then if timeout is saying promise, then it goes.
That's right.
So in this, when you have it, if timeout is saying reject, not really going.
Yeah, so here, if we were to do like 1,000 milliseconds and then it should reject, it'll go right in here. So, yep, exactly. And if you wanted, like earlier we talked about how, like, well, what if I don't care as much about this request? This is like an optional request, and I still want to recover from that. Then you can just put a catch here and fail gracefully, and then put the rest of your stuff in another try catch. Everything works. So visually and conceptually, async await is actually quite simpler, but it can be tricky if you don't understand promises, and especially when dealing with an async function, like at the root level, like we're doing here. You have to use promises. You have to use .then and everything. So it's important to understand how to use promises and how they interact with the async await. So one other kind of fun thing to note is that remember that, like, if you think about the order of operations here, what is happening first is this statement right here is executing first. And then, based off of whatever that resolves to, we're going to await that. And so long as whatever happens on the right side of await evaluates to a promise, then we can await it. So that means that you can do .then on this and .catch, and you can do whatever promisey things you want to on that side, and you can still await it. So the reason I bring that up is because if there was a situation where we didn't really care about this promise failing in particular, you just want to log it or something, then it's actually, you don't have to break it out into its own separate try-catch like we were doing before. You can actually just put a catch right here and handle it, and then the rest of the promise chain will continue. Yeah, the rest of the code will continue. It'll just, this response will be whatever you return from this catch. So here if we say hello, console.log response, and we'll see hello right there. Yeah.
And is this promise.all where go will for all the other result?
Yeah, so sort of. So like if we look back up here at the Go promises, here, and we'll, instead of P1, we'll just return. So what's going to happen is the promise that's actually returned is the one that's created off of this last .then. And so when this one resolves is when Go promises will resolve. So a call to Go promises would resolve. And this one won't resolve until the previous promises that it's chained on resolves. So it's not so much a promise.all, because a promise.all would be all of them run at the same time. But in this scenario, this is more like chaining then, and they are one at a time. So I'm glad that you brought that up, though, because there are often cases where like you don't care what order they run in. And so in those situations, you can do const promises, or let's see. Yeah, I guess this is, yeah, const promises equals this, and then we'd have timeout. Here, I'm going to get rid of all this stuff because it's throwing my groove off. Okay. So we'd have timeout 100, and then timeout 200, timeout 300. And then we could say results equals await promises, or promise.all promises. So now all of those will go at the same time, and we'll wait till they're all done. Similarly, you can do erase. So literally anything that returns a promise can be awaited, and these themselves are promises, but we pass them to promise.all, which returns a promise, and so we can await it. So in this situation, I didn't talk about this when we were talking about promise.all, and I should have. But if I were to .then, the result is going to actually be an array of each result in the same order as the promises. Should have mentioned that, because that's kind of an important piece. So in the same way, the results object right here, or the results value, is going to be an array of those values. So we have array 1, 2, 3. Oh, yeah, great question. The result is going to be the result of the first one. Yep. Yeah, and promise.all will always be an array. So even if there's only one item, it will always be an array. Okay. Let's see, and oh yeah, so a common pattern for something like this is destructuring out the results. So R1, R2, R3, and then you can use them separately. So you could say like, we have code in our code base where it's like get user and get post, or not post, we don't do post, but like get transactions, whatever you want it to be. And then just in here, it is, we destructure it to user, post, transactions. So the promises equivalent to that is a little bit less straightforward, and so this is really nice to have that. Huh? Yeah, good. I'm glad. Okay. But yeah, let's, just for fun, we'll run through this because I think this is really cool. So we make a new promise with the first time out, second time out, third time out, and then another promise with all. And then async await implicitly creates a then and a catch for us. And with async await, the catch is just throws whatever the result was. And then the then will return to us our results. And so then we kick things off on that relationship in the promise to all. The first one resolves, second resolves, and then the third resolves, which resolves the all, and then that resolves our catch. Logs our result. Trying to think if there's anything else, but I think that's pretty much it. So on the testing side of things, there's just a fun little thing you can do. You'll notice I kind of do it for you. So with our tests, remember await can only be in functions that are async functions, and arrow functions can be async functions. So here in our tests we have the async in front of these arrow functions, but that's really important. You should probably have a linter in your project that will lint if you are using the async keyword but don't have await in there, because if you don't, then you probably don't need it to be async. And also, you should have your linter set up so that if you use the word await, it will lint if it doesn't have the async keyword on the function, because those are common mistakes. But you've already got it on here, so yeah, feel free to convert these promises to async await, and ask me questions if you get stuck. Weird things going on. All right, so it should work with resolved promises. So do async. If you don't pass reject promise, then that defaults to false. So this one is going to go into our then. We already have async on here, so I kind of did that for you. But we want to get the result, and we want to wait for that result. So we'll delete that and that. That goes up a little bit. And get rid of that error thrown, and we want the result to be resolved. Save that, and it's passing. So that was simpler, right? It's kind of nice. Love that. Okay, and well, that only on this one. And for this case, we want to catch a problem. So I'm going to do a try catch. Get rid of that. Do async, and then we want an error to be rejected. Cool. And what we could do, yeah, that's pretty much. So you wouldn't need to do a inside of a try if you're going to catch right here, because the yeah, it's not going to like unless you rethrow inside of your catch, which you could do. But yeah, that and this is like a totally legit thing to do, and I've totally done it. But in this particular example, it doesn't really show you how to use a try catch. So, but yeah, that works just as well. Oh yeah, and I hope everybody's last test is passing. All right, sweet. Hopefully that's helpful. So actually, does anybody want to share some of the key points that they submitted in their elaboration? Like, what are some of the key insights of async await? Cool. And what happens when you turn a function into an async function? Sorry, what? Yeah, return the promise. Yeah, cool. Alrighty. Great. That's it for async await. Any last questions before we move on? Okay. So this next one is a little bit more lightweight. Should hopefully be a little easier to follow. So we have ES2016, so last year's version of the spec, added, technically I think it added at least 3 things, but one of them you probably don't care about. But the 2 main ones that you that are relevant are, oh, I'm totally looking at the wrong thing. Whoops. Quizzes. There we go. Yeah, so the 2 things that we care about are array includes and the exponentiation operator. So here's the way that we've got this array, and we're saying index of 2 is not equal to -1. So that's the good old way that we used to check for whether an array includes something. We used to do the same thing with strings until we got string includes. So how would I refactor this? Well, yeah. How would I refactor this to make it so that it's not this weird imperative stuff that we're doing? Yeah. So we'd say includes, and that's going to return us a Boolean. So we can do that for this one as well. Includes, and get rid of that. And poof. We get includes 2 is true and includes 4 is false. So that's nice. That's a handy little gift. So then the exponentiation operator. I have used math.pal like a total of maybe 3 times in my life. So getting some syntax to make it easier to do that. I'm not sure why we would do that, but we did. So anybody want to just hazard a guess at how you would do this same thing syntactically? So Brian, I think you're onto something. Say what you want. Tell me what to code. Return. 3.repeat 4. Sorry, that's not it. Anybody else want to guess? Caret 4. That's a good guess. Problem is, caret was already taken by the bitwise operator. It is a bitwise operator, so we can't do that. So multiplication is that, and you could say that like power is the next multiplication, so it's like multiplication to the max. So that's the syntax. Right there is a double star. Yep, that's it. So these 2 things are the same. So fun stuff. And in fact, the transpiled version of this is kind of simple. Ta-da! That's how you transpile the exponentiation operator. So you would just give it to the power of a decimal. Yeah. So or you could do to express it a little bit more clearly. So yeah, we could do 2, or let's say the square root of 4 is 2. So yeah, fun stuff. I feel like there were actually a couple other kind of interesting facts about this, like negatives and order of operations and stuff. But honestly, like you're probably not going to use this one very much. So we do have tests for it though. Raise your hand if you want to do the tests for these 2 features. Okay, I didn't think so. But if you want to later, all the exercises are right there. Yeah, pretty normal, regular stuff. And if you do that, then provide me feedback because I'd appreciate it. Okay, I didn't think anybody really cared to do those. array includes is pretty straightforward, and you use that all the time. Array includes, I should note, let's see, includes true or blah, blah. You'll notice that if I transpile this with Babel, like in the browser right here, Babel doesn't actually put any code in there or anything. So this requires a polyfill. So if you're using Babel polyfill, that will be part of that, or you'll just need to have the polyfill available. So no transpilation for that, just requires a polyfill. Okay, great. So now we're talking about ES2017. And this had a handful of features. One of them, async await, we did that already because I thought it was relevant to keep it close to promises, so hopefully that's okay. But yeah, that's part of this. And then a number of other features. So, great, we have this function called padString. We have a string assigned to hello, and we want the string hello to be padded at the beginning and at the end by 2 characters with spaces. And right now I have it calling functions that don't actually exist, like wat beginning and wat ending. What do you think, though, like we could use to actually pad those, the string on those sides? Just like your intuition. Wrap, you could wrap it. It's not wrap, but that's a thank you for guessing. Any other ideas? I'll give you a hint. Pad. And there are 2 functions to pad the beginning and pad the ending, but it's not beginning and ending. Close. Okay, this is a silly exercise. It is pad start and pad end. Yeah, you're going to remember that though. But it looks like something's busted. Hello. Oh, right, yeah. So here's the thing. Padding is basically saying this string must be this long, and if it's not that long, I want it to be padded by X number of characters to make it that long. So it's not going to be pad start, like give it 2 padding on the left or anything. It's going to say, if you want to have 2 padding on the left side, you're going to count 1, 2, 3, 4, 5, and then 2 more than that on the left. So simple way to do that is 2, like the number of actual characters you want, plus string.length. And then on the other end of things, if you want 2 on the right side, you'd say 2 plus start padded.length. And now we get true. So end padded is 2 spaces. So, here, actually, let me just do something really quick. Yeah, so you can see it right there. Poof. So, like just a fun fact, it would be really nice if this would work, but it doesn't quite work. So you can like chain these string methods because they return new strings, and so you can chain to your heart's content. So if we did like 7 and then pad end 7, right, because we want 2 on the left, 2 on the right, that doesn't work. Because pad start is going to return me a string that is now 7 characters. And then pad end says, okay, I want it to be 7 characters, or at least 7 characters. Well, it already is, so it's not going to pad. So that's why you see here we take the original string length and assign that to start padded, and then we use start padded as our length, our base length there. So cool. So then pad string with pad string. So here we are padding it with hello, 2 spaces and hello. But what if we want it to be like 0 padded? Like say it's a number and we want to pad zeros in front of it or something. Or what if it's hello and we want to pad it with the string sup? I mean, who doesn't do that every day? So we have this pad start thing. Here, let me comment that out. Yeah, sorry. I don't want to like mess things up at the bottom. Okay, yeah, so we have this pad start thing with 17 characters, and so we are getting a bunch of empty space there. So how do you suppose, just intuitively, how would you pad it with the string sup? Somebody whispered something. Yeah, second argument. Okay. I try not to be tricky. Yeah. So now we have sup, hello, which, yeah, that's great. So yeah, by default it's an empty space, but if you want to have more, or if you want it to be something totally different entirely, yeah. And that is string padding. The same thing works with pad end. Okay, great. Another feature with ES2017 is object.values. So what do you suppose, here, let me comment out this one. What do you suppose object.values returns here, this function? What are we going to log when we save this? Sorry? See, A, B, C, or... So it's object.values. So it's going to be an array of all the values. And it doesn't go deep into other objects. So you'll see A value, B value, and then the C value, which is an object itself. Cool, cool. And then object.entries. This one's pretty interesting. If you think back at part 1, we talked about maps. That will be something to think about for this one. So what do you think object.entries is going to give us? Yeah, an array of key value pairs. Right. So A value, B value, but it's an array of arrays. Yep, array of key value pairs. Cool. And then this one, it's kind of hard for me to like quiz you on it, but here we have this function called totes legit, and it has some arguments, and they're separated on new lines each. Don't write code like this. That's really weird looking. But the last one you'll notice has a comma after it. So if we were to put this all on one line and like format it kind of nicely, then that looks kind of funny with that comma. But it's totes legit. So trailing commas on function calls and parameter lists. That's in ES2017. I think the main motivator for that, the reason why I like it, is because if I wanted to add another argument here, I'd say foo, and you can't really see it very well, but there's a green line there. That's Git saying, hey, you added a line. Before, it would be like a change. You changed this line and added this line, and that was really annoying. So I like it much better when I can just add one line, and on Git it's like you added a line, not changed a line and added one. So anyway, that's like the main motivator. Yeah, one interesting fact about this is if you use rest params, you cannot use a comma. That's syntax error. The reason for that is you can't have anything after rest params. Doesn't make sense. So no commas after rest params. And the same thing string. So string equals. It's like on the other side of things, though, it's totally okay to have things after, and so like you can have a trailing comma on function call with that. That's totally fine. Any questions about that? Okay, cool. So I am going to have you go through the exercises for this one. So that is exercises 17, ES2017. And this one's kind of fun. There's even like code that's in a string that I made a custom assertion to make sure that the syntax is correct. It's pretty wild. If you want to, like, if you finish early and you want to explore how that works, go to common helpers expect all to be valid, or expect to be valid syntax. It's a custom jest assertion. It's pretty cool. But yeah, run through that and let me know if you have questions. So real quick, I just thought of a kind of a cool use case for object.entries, which I think you might be interested in. So like I will often do something like this, where if I take this, here, we'll do this one. I can take this object and I'll say, okay, object.keys, object for each, and get the key, and then I'll say cost value equals object at key, and then I can do something magic, right? So that's super cool and everything, but I'd actually much rather do entries for the object and then destructure out the key and the value. And then I can throw that away, and now I can console log key and value. So that's actually something I've never done before, and I just barely thought of as a great use case for object.entries, and I will probably be doing that more. So yeah, great. Everyone refreshed, ready to start out with public class fields. Okay, public class fields. How many people here are doing React stuff? React? Yeah, Denver. Yeah, my boy. All right, cool. React is great, and public class fields are very applicable for React users, but also I imagine really useful for Angular people too, maybe? I'm not sure. I haven't done Angular in forever, so. Yeah, pretty useful. It kind of compensates for one of my least favorite things from ES6, which is classes. But yeah, it's nice because it makes things a little simpler, I guess. Okay, let's talk about it. So there is a bug in this code. Trying to think of how I can show you all of it to you. Where's my... I'll walk through it with you to speed things up a little bit. So we have this class greeter. It has a constructor, takes a name and a preference, it assigns those to the instance. The class has a greet method, ask about weather method, and a get interesting callbacks method. So the greet method takes an other name, and it uses this.name as part of it. Ask about weather, gets the enter preference, and anyway, it constructs a string. It doesn't matter really what it's doing, but it uses this preference in 2 places here. And get interesting callbacks returns an object that just gets you the greet and the ask about weather functions, so you can just get those. This is a little contrived. You wouldn't really do this get interesting callbacks thing, but anyway, interesting functions here. So then I have this get interesting callbacks object, or this interesting callbacks object for this greeter, and when I call greet with Jane, that's greet, and it's going to say this.name, so presumably that would be Ronald. So hello, Jane, my name is Ronald. And then interesting callbacks ask about weather would check the preference, and Ronald prefers it cool. So there is a bug, and it starts right about when I make these function calls. I think you know.
Yeah,
Exactly. So right here where we pass it this.greet and assign it to this greet variable, and then this object is what that object is. Interesting callbacks will be what this context is referring to inside of our greet function, because that's on the left side of the dot. So thank you, JavaScript, and you're really weird, this construct. But yeah, if I uncomment that, I'm going to get the greeting. Why am I getting it twice? Because that. Okay. let's just run that again. So the greeting, hello Jane, my name is undefined. And is it cool outside? I prefer it undefined. Yeah, that's not very cool. So yeah, can anybody explain why this is happening a little bit? Like what, why are we getting undefined? I kind of explained it already, but just to rephrase it or say it again in your own words. Why am I getting undefined here when I should be getting this.name? So let's see if I put name here, Freddy, then I'm going to get Freddy, right? Cool. Okay, so that's not very fun. In a React component, you would see something like, let's see, class component or my comp extends component, so that would extend from React.component. And then you'd have like handle click and render, and then you return button on click equals this.handle click. Click oops. So if I used anything .log this in here, like this is where this problem comes up in like actual everyday code, in my code all the time, is I'm passing along a callback that I have on my instance, pass along to something else. That something else calls that, but it's not calling it with the right context, and so this is not set properly. So there are a couple of solutions to something like this, and that is we could say this.greet.bind this, and so now it will always be bound to the right this. We could also say greet is equal to an arrow function that takes any number of args and forwards those along, but that's not very fun either. So a final solution, to take this back to where we were. Yeah, a much better, cleaner, more straightforward solution is to actually use public class fields. And that looks like this. So it's the equal sign, and then whatever you want it to be assigned to. So if we back up actually for just a second, maybe another way that we could solve this problem is actually to say this.greet equals, how did I explain this a little? Here, let's go back. So sorry, another solution that I didn't talk about also, and this is actually was until this feature, was really common with React, is you'd say this.greet equals this.greet.bind this. So, and you'd have like a billion of these inside of your constructor, and it was really no fun. So what effectively, and like because of arrow functions, yet another thing you could do is define the arrow function in here as well. And because these, other name. And because arrow functions cannot be bound, they have no scope, whatever, or no or this binding, then this would work as well. So effectively, what you're doing when you use a public class field is you're just taking this, pulling it out, and getting rid of that. Those are functionally the same thing. So I can put it back, this.greet, or I can pull it out. And as far as like when this code is run or whatever, it's run at exactly the same time at the end of the constructor. Greet on our instance will be assigned to this arrow function. You can do the same thing for like any value. So it could be favorite number equals 32. And yeah, pretty much anything else. That's public class fields. the important and maybe sometimes confusing piece of this is that like most of the time, maybe not so much anymore, but like especially in ES5, most of the time when you came across an equal sign, that equal sign runs is evaluated at the time you see that code, like at the time that code is run. But in this case, it is going to be run inside the constructor. That's the important takeaway here. Okay, so to fix this, we'll just finish, save that, and stuff's broken. Who knows why? I do, thank you. Get rid of that. There we go. So, hello, Jane. My name is Ronald. Is it warm outside? I prefer it cool. Okay, any questions about that? Cool. So for our test, we have a React, sort of React example. We have this fake React component thing, and it has a render that doesn't actually do anything, weird JSX stuff here. So yeah, basically the goal here is for us to not have to do this silly thing and migrate, convert it to a public class field so it's auto-bound. We don't have to do this thing anymore. Sorry? Sorry, what about super? Oh, actually, so when you have a constructor, if you have a constructor, then it's not going to automatically call super for you. And so if you want the super constructor to run, then you need to call super. Yeah, because in this case, we're extending something. All right, cool, friends. So let's do this. So you might have noticed that the test actually does already pass, so it wasn't like make this pass. It was mostly use the right stuff. So the goal is we don't want to have to do this, so I'm going to get rid of that. And you know, a fun fact, when you have nothing in your constructor but a super call, you can get rid of that constructor. So that's cool. Don't need the constructor anymore. Oh, why isn't it broken? It should be broken. I guess this never really actually showed the bad behavior, which is too bad. Test break. Oh yeah, that's because we're calling. Okay. Anyway, syntax though, that's what we're caring about here. So you just turn this into an arrow function, and we're having we get the same semantics as if it was in the constructor. So okay, I need to improve that example, but hopefully at least you get the syntax, and if you're doing this syntax, it should work, or potentially pass. Okay, make sure to do the elaboration piece and feedback. Okay, great. Symbols, not like instrument symbols, but like coding symbols. Okay. Yeah, so if you don't have a constructor, then the default constructor is it's a constructor that calls super with the arguments that it's given. So if we go back, so this is the default constructor, basically, functionally. So if you don't have it, it does the same thing. The only time you really need a constructor is if you need to do things in the constructor that are special. So that's one of the reasons why I really like this, because also like in a React context, if you have state, like with ES6 classes, you're going to say this.state equals my initial state, whatever I want it to be. But because you can do public class fields, you can just say move that down, get rid of this, and it's the same thing. And then you can actually, it's kind of funny, you could do this as well, which would be kind of weird. Just do that. Sorry, what? Yep, exactly. So if you do have a constructor and you don't call super, then this code won't run. And that, especially in the context of React, but like anytime you're extending something, the code in the parent's constructor is probably important. So, yep, get rid of that, and poof, magic ensues. Okay, cool. Huh? Everything. Oh, you do? Oh, yeah, that's true. Yeah, lots of stuff was borrowed from Java, and some people are really mad about that. So, um, yeah, it's funny. That's the thing. Is like JavaScript. Pretty much everybody has to write JavaScript eventually, whether they want to or not. And so, yeah, and so it's lots of different opinions and stuff. So the only reason I use classes at all is because React requires it. But that eventually will no longer be the case, and then I will probably never use classes again. So yeah, I like functions and closures and objects. And, yeah, but. Okay, cool. So symbols. Symbols are cool. Hold on. Did I? Yeah, okay. So a symbol, giving some background information on symbols, it is a new primitive data type. So who wants to rattle off all the primitive data types in JavaScript? I'll give you one. It's string, number, object is not, null, undefined. Everybody's going to be like, oh, yeah, Boolean. Yeah. So number 6, symbol. It is at the same level. So here is how you don't create a new symbol. Not with new. You don't construct a symbol. You simply invoke the symbol, like first letter is capitalized, and that gives you a symbol. And this is how it's represented when you like console log it out. But that's not really very helpful if you have, like here, let's return an array of symbols. What just happened? So now I've got a bunch of symbols and I can't differentiate them, and so you can actually give them an identifier for debugging purposes. So how do you suppose I might do that? What? Like a description or some sort of identifier, something to make it easier for debugging. Intuitively, how would you expect to be able to pass some sort of description? Yeah, so a string right in here. Hello. And then as you're debugging, you'll get, for your output for your symbol, it'll have the description inside of the parentheses. That is 100% only for debugging. There's no actual use or value to that. You can have a million of these symbols that are have the same description, and it all works just fine. There's nothing, it's not really an identifier of any kind. It's just something useful for debugging purposes. Okay, cool. So symbols from an object. So here, because we have this great new feature for object literals, where we can have computed properties, we can now not only have properties of objects that are strings, but also properties of objects that are symbols. So a symbol can be an object property. And we're setting one here in our object literal with no secrets, and then secret as the key being the symbol. So my question to you is, what does object.keys for that object return? So it's no secrets and nothing else. Oh, sorry, is that? Okay, that's, there you go, no secrets. So that is an important little fact. So object.keys, you will not see the secret. Also, if we were to do json.stringify the object, then we're not going to get here, let me, push that up. We're not going to get our symbol in object or JSON stringify, which is kind of cool because it means you could sort of kind of attach metadata to an object without having to actually like send that metadata down to the server. I remember I would like back in the old days, I'd attach a bunch of metadata information to my models, and then I'd have to clean them all up before I send that down to the server. It's really, really annoying, and not even a good way to do it during those days. But with symbols, you could just say, here's my metadata symbol that I can attach to that. And this secret symbol right here has no special attachment to the object. So I could create an O2 and have secret here. That's totally fine. I can use this symbol to be like the special way that I can get this metadata off of these objects. And that is done all the time. Yeah, I'm trying to think. There are some built-in symbols, so I can't remember them all off the top of my head, so I'm going to pull up the good old developer tools here. Symbol dot, let's see, we have toString, toPrimitive, let's see, yeah, iterator, yeah, match, I think that's a symbol, yeah. So there are a bunch of, I think there are like a dozen, let's see, object.keys, maybe? Yeah. I don't know how to find them all, but yeah, there are about a dozen like built-in symbols that have some use, like is concat spreadable, and they're all like tacked onto the symbol constructor, and you can use them to enhance your objects so that you can have a replace for your object or a match for your object. Yeah, it's pretty cool. There are a couple other things. We're going to talk about iterators, actually, the symbol iterator built in. I'm not going to talk about symbol.for and symbol.keyfor. Well, I probably should. I don't have any examples for this, but there's. I'll just mention it briefly because it's not really something I would recommend using, like pretty much ever. But there is a global registry of symbols. So one of the key important pieces of symbols is that when you assign an object property to a symbol key, then the only way for you to get it is if you have that symbol. So if I return this object, it will be impossible. It's not impossible. I'll show you a way to get it differently. But it will basically be unreasonable for anybody to get this value without having the symbol that it was assigned to. So there's a global registry of symbols where you can say, here's the symbol for this, and you can give it a name, and that's its ID in the global registry. And then somebody else could go get that and say, okay, get me the symbol for this type of thing. So like the metadata of my app symbol or something like that. Global registries always scare me, and so I would recommend against using that. But yeah, if you ever wanted to look into that, you can learn more about symbols here. Let me think of. Oh yeah, let me show you how to get the symbols. I can't remember it off the top of my head because I don't do this all the time. So it's object.get. Here we go. So if we return capital object.get own property symbols for object, then that is going to give us an array of all the symbols that that object has for it. So we could create even a symbol here and make that an object or something. Now we have that empty symbol. We could do like, yeah, I'm sorry, this is unfortunate positioning of my head. But yeah, we could do a bunch of those, and they're all unique. You know, every single symbol is unique, and so we can get the symbols, but it's not really reasonable to do that. So practically, the only way to get something from an object that is identified or keyed off by a symbol is by having the symbol itself. Yeah. So like maybe you could have a list of all of the symbols that are relevant for your app from like in some module or something. So you import that symbol, and you use that symbol to assign a property somewhere onto object. Sorry, your question about practical use? Or?
So, symbols usually would have because for each flow for that symbol.
Yeah, I'm not sure. Yeah, so as far as like actual use cases for symbols, I have yet to create my own symbol and use it like throughout an application or something. But the built-in symbols, like symbol.iterator, allows you to make something iterable that it like is not normally like an object, for example. And we'll talk about that next. Yes, iterators are next. Yeah, I think one of the cool things about some of these features in the latest version of JavaScript, and this actually is an ES6 feature, is that it enables us to do things that were impossible before, like assigning non-strings to objects that are not enumerable. So like if you did for of or for in on this object, then you're not going to see the symbol on there. So cool. Okay, so let's go ahead and practice up with these symbols in the exercises number 19. Yeah, and then we'll move right along. Oh, I'm sorry, I didn't leave a good comment for this first test, but basically I want to make, I want you to take this string and change it to a symbol or like create a symbol out of it instead of the string. So assign symbol to an actual symbol. Okay, cool. Great, let's do this. Symbols. So creating a symbol, we're going to simply say a symbol, and that will give us a symbol. Here, let's do not only so we keep up with what's going on. So then we can give a description, and if you looked down, you could see use the force was the description that you needed. And symbols are unique, so even though they don't have, neither one of these have a description, these will not be equal to each other. And even though these have the same description, these will also not be equal to each other. So every symbol is totally and entirely unique. That's like, as opposed to like strings and booleans and numbers, right? If it looks the same, it is the same. But not with symbols. Symbols on objects. So we're going to create an object called game, and it needs to make the test pass. So we look down here, okay, it needs to equal this. So we'll just copy paste that. And then it needs to have a symbol using that symbol. So we'll say symbol, and that's an object, it looks like, and it looks like that object is this. And so that's why here we say JSON stringify the game, and that will create a stringified version of game. Because symbol is not included in the JSON, it's excluded here, and then we parse it to make it a new object. And so that's why it's that. Cool. And anybody have any questions or trouble with that? Confusion? Everybody fill out the feedback and do the elaboration stuff? Okay. Great. Then let's move on to iterators. So at the beginning of the workshop, we talked about promises. That was pretty heavy stuff. Now we're talking about iterators. This is pretty heavy stuff too. But it's wicked sweet. So I say that, but I've never actually made a custom iterator before. But understanding iterators is great. So let's start out with getting an iterator, or before we even start that, let's talk about what an iterator even is. Okay. So an iterator is something that you can iterate over. Sorry, that's an iteratable. Iterable. So actually this this should be renamed to iteratable. Iteratable? I don't know. Here, let's find out. Iteratable. What does Google tell me? It says you're a moron. It's iterable. Iterable. Okay, well, if you didn't learn anything else, at least you know how to spell iterable. So, yeah, an iterable is something that can be iterated on. And here we're using the raw API for iteration, or the iterable for an array. But the way that it would be otherwise is here we have an array for let x in array. Here we're iterating over the array. There's this cool new thing called of in ES6, and that actually uses the iterable API, I guess. I don't use for loops very much, like pretty much ever. I pretty much never use for loops, but as I use more iterables and maybe like generators and stuff like that, maybe I'll use it a little bit more. Yeah, it's basically this capability to take an object of some kind and define what should happen when somebody is iterating over that object. So arrays, and for something to be iterable, it needs to implement a function at the space symbol.iterable. So we just learned that we can assign properties to symbols on objects. So an object can have a symbol for a property key. And one of the built-in symbols is iterable. So symbol.iterable is actually a symbol itself. We assign a value to symbol.iterable that is a function, and then that function is used to do the iteration stuff. Okay, so maybe to make it a little bit more clear, let's look at our console stuff here. So we have our array. It's not a function. Oops. Symbol.iterator. Oh, haha. My refactor, iterator. Yeah. You got me. Okay, so iterator is going to be a function. It's native. You want to know what else is natively iterable? A couple cool things. Strings, natively iterable. Numbers, not natively iterable. Objects, also not native. Well, hold on a second. Var x equals objects x. Yeah, I don't know what that was all about. That was weird. Oh, I know, because that's a block in my console. I just created a block, empty block, and then I did symbol as in an array. That's what happened. Fun stuff. Okay. Yeah, there are a couple of things. I'm trying to remember what else there. Oh, maps. So a new map. Symbol.iterator. That's basically entries. Set, week map, and week set are not because it's impossible to know what's inside of them, right? Like that's kind of the whole idea. You have to actually have the key to get anything out of it. Yeah, I'm trying to. I should have a list somewhere, but there are a handful of things that implement symbol.iterator. And when you call the symbol.iterator function, you get back the iterable. And this iterable has a function on it called next to get the next item out of it. So with all that information that you've just learned, what does this return? We call iterable next. As a hint, the first one returns, or the first call to next. My startup disk is almost full. What? Okay, so let's take a guess. What are we going to get back when we return this object first, second, third, fourth, and fifth? So what will first look like? I tell you, it's a hint. It'll be value 1 done as false. Second will be value 2 done as false. Yeah. Third will be 3 and false, or 3 and false, or 3 and true. True. And fourth will be, okay, and fifth will be, okay. Let's see what happens. So first is value 1 done false, value 2 done false, value 3 done false, value undefined done true, done true. So that's kind of fun and fancy free. So part of the reason for that is it's something that I don't totally understand exactly, but I think it has something to do with the for of. So like if the semantics of it, once it hits done, it doesn't run your block. And so it needs, or once done is true, it doesn't run your block. So it, in the case of the array iterator, it says done is true only when I've reached the end of my array. So let's just look what happens if we skip an item. Actually skip an item. So we're going to get done is false, even with the value of undefined, if we skip an item. So that's kind of interesting. So let me just look through it. Yeah, okay, we'll talk about that later. Sorry, and I keep forgetting that like you can't really see that very well. Okay, so built-in iterables. Oh yeah, we talked about this right here. So which one of these is iterable? I have this function called isIterable that takes a thing and it casts thing symbol, the iterator, to a boolean so we can see true or false. So in your mind, try to answer these questions. Is an array iterable? Boolean, string, object, number, function, and you know I kind of cheated because like it just needed a function, right? So I just passed it to itself. A map, a weak map, a set. I should probably weak set matters too. And a generator. We'll talk about those later, maybe. And then calling a generator, so what you get back from a generator. So, how many people here have heard of generators? Okay, yeah, they're kind of this weird esoteric thing that not many people know a whole lot about, but they're pretty interesting, ultra powerful, and really confusing. So let's see what it actually is. So we have an array is iterable, boolean is not, string is, object is not, number is not, function is not, a map is, a weak map is not, set is, a weak set is not, a generator, the function itself is not, but what you get back when you call a generator function is. That's a very important point. So we'll learn more about generators later. But here's one of the cool things about iterators. This is like once I saw this, it was like, oh, now I care about iterators. It is that you can rest and spread them. So here we have a string. We're going to ... string cross, and we have a set. We're going to ... that set, because set is iterable and string is iterable. And then you can also rest that set because that set is iterable, and we're going to return the rest. So just for fun, who wants to take a guess at what we're going to get back from this call? Honestly, it kind of, to really get the right answer here, you kind of have to know what the set iterable does. Like how does this set iterable, how is it implemented? What does it give back to you? I'll just tell you it gives you back an array of values. And so for us, let's get rid of this. That's going to be, heyo. Yeah, it's kind of confusing, to be honest. But it, that actually surprises me. I can't remember how this worked. So we have our set and our string and our combined set. So the combined set is a set with one HEYO. That's right. That's right. So, oh yeah. Okay, let me explain. This makes more sense now that I'm thinking about it. So we have one HEY. We add all those to the set, and then we add a set with H and O. But H is unique, right? And so then we have a set that is one HEYO. We're skipping the first item, and so we get rid of that, and that's why we end up with it. Sorry about that. Contrived examples are sometimes tricky. Okay, cool. But hopefully they're not distracting. So now, custom iterators. So this is going to blow up because cars is an object. Objects do not implement symbol.iterator. This is where things are going to get a little heavy. So prepare yourself and prepare myself. In fact, I'm going to prepare myself really quick. Yeah, okay, got it. Okay, so to implement symbol.iterator, we simply create an item on the object. It doesn't have to be inline. We could also do cars symbol.iterator and assign it there, but I'll just do it right here. Symbol.iterator. What would I do without autocomplete? And that's going to be a function. I'm just using shorthand for here because I'm lazy. I remember just now I bumped my font size down. Do you all need it to be up? You can see it okay? Okay. So an iterator function is a function that returns a function. And so we're going to return a function. And here we want to, actually you can run into an infinite loop with iterators. So if I were to actually save it right here, oh, it's not a function. Hold on a second. Yeah. Oh, right. You need to return an object that has a next function. Sorry. Now if I were to save it right here, it would blow up. Not an object. Oh, return an object. There we go. Now it's going to be an infinite loop, and it's like, stop. So I'll stop. So basically what's going to happen when you do, oh, yep, okay, don't do that. When you do this ... it's going to say, okay, run through the iterator, just keep going. Just hit the iterator until I get done. Done is true. Okay, so what I'm going to do here is I'm going to first, we'll return done is true, and value is, I don't know, it can be anything. It doesn't really matter. It's our iterator. We do what we want. No, iterators. Okay, cool. So in here we wind up with an empty array because we specified done is true. And so the value doesn't actually mean anything because it's like, oh, you're done, so I don't care about your value. So for us, we actually do, well, what we want is, I can't remember what our end goal is here, so hold on a second. Value. Honestly, I can't remember what the purpose of this iterator was, so hold on one second. Okay, yeah, we want all the values. So what we're going to do is get all the values for the car. We can say, here, let's console log this. And we're going to get the object itself. So this is bound, which is pretty neat. So we can say object.values of this. And we could actually, here, let's console log that. And object.values itself is iterable. So if we really wanted to, we would just say object.values cars symbol.iterator. And, haha, cars is not defined. So if we did cars, okay, this is why I shouldn't test things out in the middle of actually teaching things because I don't know what I'm talking about. Okay, so we have our values and we want to iterate over them in our iterator. So I'm just gonna say this as values. And then inside, every single time our next is called, we're going to bump up to the next item. So I'm gonna create some state here. called current index is 0. And actually, we'll start at -1. And then at the top of our next function, we're going to say current index plus plus. And for our value, it will be values at the current index. And then for done, we'll say that current index is greater than or equal, or is, yeah, greater than or equal to our values.length. And then we get what we're looking for. So we iterate over the value, we can now iterate over the values of this object cars. So we can ... we can spread, we can rest on it because this implements symbol.iterator. Like taking away the contrivedness of this example, the key pieces to take away for custom iterator is to first implement a function at symbol.iterator for whatever it is, the object, the date, anything that you have. And then that returns a function that returns a next function. And then inside of that next function, you return a value and a done. And if your done never makes it to false, then you've hit an infinite loop whenever somebody tries to do something like this. Or if somebody were to try to do for on your iterator too, without like any sort of blocking or like breaking out of that. Yeah, any other questions? Cool. Okay, so I realize that we haven't talked about, that's what I did. Yeah, so I realized we haven't really talked about the generators yet, but I'm just going to show you what it would be like to convert this implementation to a generator because it's kind of neat. So I'm actually going to just keep working on this one example. So instead of storing all of this state, like the current index and the values and making sure to call or returning next and all this stuff, because a generator is actually both iterable and it is an iterator. And so we're going to assign our symbol.iterator to a generator function. So I'm actually going to change this to function star. I don't know how my formatter wants this. There we go. Unnamed generator method. Oh, okay. Heck with it. So if you want to make a generator, you add a star to it, a star to the function definition, and that turns it into a generator function. And so now, this function, when called, does not actually return what it looks like it returns. It returns an iterator. That iterator you call next on forever until it says it's done. So we can get rid of a whole bunch of stuff. So we're going to take this values, and I'm going to say, for constant value of values, yield value. Get rid of all that stuff. We have the same thing. So the generator kind of hides away all of that state for us, just using a fancy star thing and this yield keyword. I kind of doubt that we'll get to talk at length about generators, and to be honest, it's unlikely that you'll use them yourself unless you're using something like Redux Saga, in which case I think you could learn about that. I wouldn't say it's straightforward, but the use cases are kind of far and in between, and async await handles most of the use cases you need for something like this anyway. But if you're ever going to make a custom iterator, generators are the way to go. They're like very clearly much simpler. Okay, cool. So that is iterators. Let's go ahead and go to the tests, unless there are any other questions or anything. Okay, cool. So we've just got a couple tests here. I think, oh yeah, there's this cool little custom iterator on built-in types. If you wanted to try that one out, that's extra credit. That one's pretty neat. And also creating a custom iterator with a generator. You can feel free to try that out. But like I said, we didn't really talk too much at length about generators, so don't worry about that one as much. I'll work through these solutions, and then we'll talk about what we want to do to wrap up our time together. So first off, getting the iterator from something that is iteratable is symbol.iterator. We'll do that only on that one. To symbol, there we go. Oh, right, yeah, gotta call it to get the iterator. Yeah, thank you. Okay, great. So that has the next, and so it is an iterator. And so we'll call next a couple times. We have hello, and we'll see H, E, L. Okay, you know what? This is silly. L and O, except this is totally not right because these are actually objects. Okay. So that'll be value is that, done is false, except for these two. Oops. The value will be undefined, and done will be true. And let's turn this test on. Okay, cool. Any questions about that one? Okay, sweet. And then we can iterate over an iterable with for. Sorry, I know we didn't really I briefly showed you this one, so this one might have been a little bit tricky. But we can say for const val of array, and then we can say sum plus equals val. Great. And then using ... over. Oops. Yeah. So it has the last two items, so we're going to skip the first and get the rest out of the set, which is iterable. And then the real tricky one, creating a custom iterator that I don't think it would be really super valuable for me to walk through it right now, so I'll just show you the solution. And it is a fun little exercise to work on if you want to. So, but basically what I did is I created a random function that is based off of this max and this min to generate a random number. And then I generated, or I created random numbers, which is like the number, a random number between the two. That should probably be called like random numbers length or something like that, or the number of random numbers. I don't know. This isn't Objective-C or anything, so long names. Okay, then we start out with index of 0. Then we determine whether we're done based off of whether the index is greater than the random numbers that we're going to be generating, and the value, if we are done, if we are done, is going to be undefined. Otherwise, we're going to generate a random number. We'll increment the index and then return value and done. Did anybody finish this one? Okay. You hard-coded your random? Well, it passes the test, right? So, excellent. Oh, tricky. Okay, cool. And then it's actually quite simplified with a generator. So we still need the random and the random numbers, but then we can just do a for loop and yield a random number until we run out of the random numbers. So yeah, yield is pretty fancy. Yield works in a similar way like await, where the function pauses the execution there until the next time the consumer calls .next on our iterator. That's kind of really brief how that works. So if we had like a console log right here, or right here, then that wouldn't actually run until the next time this iterator iterates. So anyway, I don't think that we'll get into generators today, and that's probably okay. And then here's this one was pretty cool. You should try this out later. But you could add a custom iterator to built-in types. I wouldn't recommend actually doing this in applications, but it's kind of fun. So number is not iterable, but you can make it iterable by adding an iterator to it. And yeah, so we're just, and I got this, by the way, I should shout out to Getify for his friend and master's workshop, ES6, the best parts. Really, really great workshop. And this is where I got this idea, or this was in his workshop. But yeah, so we create a number, and then we spread, we spread that number into an array of 0 through 4. Pretty cool. It's pretty handy. So, yep, that is iterators. Anyone have questions about iterators? Okay, neato. So we have 3 more things: generators, reflect API, and proxies. I'll give you a quick rundown of the 3. Generators you will probably not often use unless you're using something like Co or Redux Saga. Anybody doing anything like that? Okay. They have really powerful use cases. They're really, really, really powerful, flexible, awesome. But they're also quite confusing and would take probably at least as long as promises to explain. So we don't have time for that anyway. So actually, I'm not going to let you choose that one because it's too hard. Reflect and proxies are actually really tightly coupled. You generally use the Reflect API with a proxy. A proxy allows you to intercept regular operations on objects and things. So anytime I say like foo.bar, that is actually a get operation. I'm getting the bar value off of foo, and I can intercept that and return something else entirely, or throw an error, or like any kinds of really interesting things. Or like if I set it to something, I could do like validation to make sure that it's set properly. I would recommend that you never actually do that kind of thing. Proxies are very much a low-level API that you should only really use like pretty much never. But they're really, really powerful and pretty interesting. So we could talk about that. The last thing that I was going to talk about is how to configure Babel so that you can start using some of these things like async await. So how many of you are on Node version 4? Okay, most everybody? Okay, cool. So node.green, totally a top-level domain, will show you the compatibility of your Node version and ES2015 support and beyond. So for version 4, you'll see lots of red and some green. So version 4 it looks like 57% complete. So lots of the things that we've talked about, you are going to need Babel for. Eventually, PayPal is going to, or you're going to upgrade to version 6 maybe. Although I'm hearing whisperings that Node Infra is working on version 8 support, so we'll just like jump over 6 and go straight to 8, which would be like so awesome. But in any case, version 8 and version 6 are both at like 99% complete for ES2015. Cool thing about version 8 though is it will have native async await, which is pretty rad. So so in any case, it might be useful to know how to set up Babel to do translation. So I could also walk through that for like 15 minutes if anybody's interested. Or we could just talk about anything. We could shoot the breeze. Because we're in Shoot the Breeze. It's like the ring name. It's hilarious. Okay. So what does everybody want? Who wants to talk about reflect and proxies? Okay. I scared you away with the this isn't useful thing. Who wants to talk about setting up Babel translation stuff? Okay. Several people. Okay, great. And who wants to shoot the breeze? Okay. Hi. Great. So let's talk about setting up Babel. Yeah, because I don't have like any exercises for you. This is going to be more like a I'll show you kind of thing. So sorry that's not very fun and interactive, but that's just the way it's going to be. So, oh, I just opened up Atom in my home directory. I don't want it there. We're going to go to the desktop and temporary. Okay, so we bump this up, and I'll open Atom here instead. Okay, so inside of my temporary directory, I'm going to do a couple things. Actually, quick question. How many people here are using Yarn for your projects? Okay, this is like the only time you've ever used Yarn? Yeah, Yarn is so awesome. It's so fast. I love Yarn. It's really similar to NPM though, so I'm going to continue using Yarn, and I'll just tell you what the NPM equivalent would be. So the first thing that we're going to do is yarn init y. So the same thing, npm init y. They'll do basically the same thing. That's just generate a package JSON for you with defaults pre-filled. And I have my environment configured so that it knows who I am and what my license are, my preferred licenses and stuff. So the next thing, so you need a package JSON. The next thing that you're going to need is are a few dependencies, and we'll make those dev dependencies. Kind of depends on how you do things, but you should probably like do all the transpilation first, and then you'll have like a build directory that's all the transpiled files, and those are the files you end up running ultimately. Except when you're developing, and you can do things a little differently. So we're going to add these as dev dependencies. Let me bump that up a little bit more. So we'll say yarn or npm install capital D for dev Babel core and Babel CLI and Babel preset env. Oh, and Babel polyfill. So all of those things. And oh, sorry, add yarn add. It's equivalent to npm install. Except it's not the equivalent because it's so much faster. So it's like much superior. Great, so we have our dev dependencies in here. And now we're going to, let's go ahead and I'll touch or we'll make a source directory. And inside of the source directory, we'll make a index.js and a mymodule.js. And so inside of this index, we're going to import, I don't know, like add from my module. And then we'll console.log add 1 and 2 and 3. Oh, exponentiation operator, 4. Yeah. So I'll add 1 and 3 to the 4th power. And then in here, we'll export add function A and B, and return A plus B. Okay, cool. So next thing we'll do is we want to transpile this stuff. So if you notice in the node modules directory, there's a bin directory, and inside of here you have a couple binaries you can use, and it's super cool and fun. And if you go to node modules.bin Babel and help, then you can use that binary. Check this out. If I say which Babel, here, that will tell me what Babel is pointing to, and I've set up my bash so that it will point to the local node modules version, but you have to be really careful when you do that. So if you want to know how to do that, ask me, because if you don't do it right, then you could get hacked really bad. Yeah, so I can just say Babel help, and let's see what we have here. We're going to eventually make this an actual script, but for now, we want to, okay, I'm not going to look through this. All that we're going to do is say Babel, the source star, or we're going to put this in quotes, source star.js, and that's going to output the Babeled version. But you'll notice that it's not actually doing anything to our code here, right? That's because Babel needs to be configured to do anything useful. And let me just check something really quick, because as of today, something new was just merged. that is super awesome that changes how you configure Babel, or gives you another way to configure it. It looks like the last release was 3 weeks ago, so that hasn't been released yet. So we'll do the old way. The new way and the old way are really similar, so it's not really a big deal. But you're going to create a Babel RC file in here. You can also configure Babel and package.json, but don't worry about that. Babel RC. And this is basically a JSON file. So we'll have some, you can have plugins and presets and parser options, a bunch of different things. But we installed the Babel preset env. And so, let's see, presets is an array with our preset that we want to use is env, and we want to configure it. So the Babel preset env is really cool because you can say, here are the node environments that I need to support. I also need to support some browsers, like the last 2 versions of browsers or something. And this preset will, based off of your configuration options, will determine the transforms that need to be applied to your code to support those environments. What's really cool about that is it can be optimized to whatever environment you're sending it to. So if you're using like arrow functions, they're more terse than a regular function, and so you're sending less stuff to the browser, which is pretty cool. You're also, like, the things that Babel has to do to make sure that const and let work properly are a little less performant, and so if you can use those in your actual environment, that's a good thing. So yeah, for us, we're going to configure it to, let me just check on something really quick. Nope, that was the wrong package. Okay, so the way that you configure it, you can look up in the README, but we're going to configure it with targets and node 4. So we only care that our stuff works in node 4. So long as a feature is supported in node 4, that's great. So now if we run that Babel across our source, we're going to see things a little differently. We're going to see our import statement was changed to a require statement. That exponentiation operator was changed to math.pal. We have this weird defined property thing. And our function, our exports, our add export thing was changed to exports. So it's using CommonJS. So yeah, cool. So we want to actually put this somewhere. So we'll say out_dir, we'll call it dist. And that will stick the, whoops, we want it to be, how did I, hold on a second, let me, because I don't want it to be dist/source, I just want it to be that. Let me just see how I do this. I actually have a generator for all the projects that I create that does all this for me. That's why I have to look this up. So sorry about that. So build. It's fine. Oh, okay. Yeah, okay, so we can do it this way. Out there is dist, and source is what we're, the files we're transpiling. Cool, so let me delete this. We run that again, and dist, like magic, has our transpiled files. So now if we run node dist, we're going to get 82, because that's 3 to the 4th plus 1. So who knew? 3 to the 4th is 81. So cool. Now we have that set up. Let's go ahead and add that script to our package.json scripts. Build. And we'll just copy that. Now I know, like, lots of you probably are doing like the Kraken sample app, and that has like controllers and routes and the whatever other files like models right in the root directory. So you'd probably have to do something a little bit more clever with the things that you're going to actually be transpiling and where they transpile to. I would probably still transpile to a directory called dist or build or something like that, and then that directory would have controllers and whatever. Yeah, it kind of depends on the way your project is set up. But I really like to have all my source in this SRC directory, and then I put controllers and stuff in there. But I know that some things are set up differently. So great. So now we can. Another thing that we want to do, so that like as we add and remove files to this, we want to make sure that the dist only has the files that we cared about. So if I remove or rename this to modules and then I rerun that build, I'm going to wind up with the old my module and my modules. So we're going to yarn add as a dev dependency rim/raf, and this will allow us to first in a pre-build rim/raf dist directory, and and then we yarn run build. That deletes the dist directory first, and then recreates it when we run our build. So that way, a dist directory is clean every single time. Okay, cool. So yeah, so that's actually pretty much it for the translation. I feel like there was something else I wanted to mention about this. Oh, yeah. So let's say that you're using array includes or something, or like something that you need the polyfill for. All that you need to do for that is import Babel polyfill, and it'll poof populate all your stuff with the polyfills. I think there may be a way to fine tune what you're importing from Babel polyfill, because like Node 4 I think has string includes and stuff like that, which you wouldn't need those polyfills for. So like I wouldn't do the whole Babel polyfill for the browser necessarily, but for Node it's probably not a big deal. So something to look into a little further. What do you think? Does anybody have any questions about this process? Pretty straightforward, hopefully. Yeah.
We were using iterators. We were able to solve for tracking projects like this.
Mm-hmm.
That
Yeah, let's do that really quick, because that would be pretty applicable for everybody here. So let's do routes route.js, and we'll say export default function something, whatever, doesn't matter. And we'll do another file, controllers, controller.js. And then what else you got? Models. Model.js. Okay, so whatever it is. And so then here in the package JSON, let's see, we do controllers, models, routes. I think that would work. Let's try that. Let's see what it, yeah, so it's going to flatten them for us, and there is a special Babel thing that, oh yeah, sorry, one other thing before I get to that. Sometimes you'll have like a foo.json. So you'll want to copy those JSON files over, because like maybe inside a controller you like import thing, your config, whatever. So you want that to be moved over to the dist as well, and so you can do that with -- copy files, and it'll copy all the non-JavaScript files over for you. Let's see. I think it's.
so while building our recommendation, this folder again.
Yep. Yeah. When you actually run, you run in the dist folder. But to make sure you maintain the file structure, I think I think we may be able to just do. Let's see if we do this. See what happens. Yeah, there we go. So let's copy that back here. And then you have to escape a bunch of things. but use double quotes because Windows won't like the single quotes. And then yeah, we can run the build. That'll delete the dist and create it. And now what on earth just happened? Try that one more time. Huh. I'm not sure what's going on, but basically, I'm sure you can make it work. So what I would advise, though, for development time is to use this thing called Babel register. And that actually has changed its location a couple times. So let me find Babel register really quick. Yeah, okay. So like during, if you want to start developing but add Babel into the mix, then you can't run just like your source code anymore. You have to run Babel first, and that's kind of not very much fun. And so there's this thing called Babel register, which will allow you to transpile all the code on the fly as it's required. So what you do is I would make a new file called index babel.js or something like that. And inside of here, you'd require Babel register, and then you'd require your index. And then pretty much once you require Babel register, what it does is it overloads require with its own functionality and transpiles things on the fly. And so from then on, everything will be transpiled. And so like during dev, you'd say node index Babel, and everything would work. Nice. An alternative also is in your node modules, you have a Babel-node that you could run. So you'd say Babel node, and then you could do source index.js, and that will basically do the same thing. So there are a couple ways you can do that. Babel also has a watch flag that you can run, and it'll transpile things as files are changed in software. Yeah, that's pretty much it. We've been using Babel for quite a while on the P2P team, and it's been awesome. So I definitely recommend. I think it's totally worth it. You don't have to worry about what features you are or are not allowed to use. And with Babel preset env, you don't even have to worry about which plugins you're going to use. I'll go ahead and commit this. And after I ignore a couple directories, because these are like huge, node modules and dist, and yeah, let's see, Babel setup example. Create. Okay, so you will be able to find that at can't see the odds, Babel setup example. And I'll paste that in our notes doc too. And yeah, that's it. So just to wrap up again, my the feedback is there, ES6 intro feedback. I really appreciate any feedback that you can give me. And other than that, I think we're done. Thank you.